Okay, welcome everybody to this second day of lectures of IPROMO course. I welcome again Professor Hans Schreier. He will continue the very interesting lecture of yesterday on sustainable watershed management in mountain areas. And today we will have two speakers. Professor Schreier will have the majority of the day of the lecture. At the end of the day, we will have a short talk by Michele Cucchi, an alpine guide, a mountain climber. I will introduce him better when it will be the right time. And he will talk about some cooperation project in Himalayas organized by himself. Okay, now I give the floor to Hans for continue the lecture. Please.
Thank you. So today we're going to talk about tourism and water, and the second talk will be on water pollution, and then we'll talk a little bit about what we actually can do to cope with all these changes because of climate change. So I will give you a lecture on innovative stormwater management, and then we'll talk a little bit about citizen science and what you can do to help us mitigate all these problems which now are so apparent. So if you look at tourism, in 2019, about 1.5 billion people were moving, and usually the largest amount of tourism is in the summer. However, in the mountains in many parts of the world, tourism is also very, very important in the winter, particularly in the European Alps. So the big question, of course, is what happened last year and this year? What will happen to projection of tourism? You can see tourism has increased dramatically because it is obviously a very good money-making proposition, but we had been contained, we couldn't move, and now the big question is, will it actually go up as fast as they have been predicting? And the mountains, of course, play a huge important part of that. So if you look around the global tourism, about 15 to 20% of the tourism is actually in mountains. And it employs lots of people. We have lots of mountain resorts and so on. And Europe is particularly of interest because it is the largest area where winter tourism is the most popular anywhere. So the big challenges now are very new. So we used to have a problem of people moving out of mountains, but now we had a lot of people moving into mountains because they could work remotely. And that, of course, means that everybody needs access to the computer network, and those are going to be the constraints. And of course, as I mentioned yesterday, many of the big servers now are moving to higher elevation to save energy for cooling. So this is a very new phenomenon where people are actually moving into mountains. And if this is going to continue, this will bring young people back into the mountains, particularly because they're going to have to bring all these experts in to make sure these servers work well. This is actually happening now in the United States, where they have moved some of these servers a few years ago to higher elevation in Oregon because they wanted to save electricity. Will we have more summer tourism? Because it's going to be so hot that people probably will go to the higher elevation just to be more comfortable. This is actually happening often in the Himalayas, where in India, when it gets too hot, they move up into Nepal for just for cooling. That will require much more infrastructure because access to the mountain is always difficult, and so with the constraint are we need to build better infrastructure to get access to these mountains. But there are options available for the electricity because we could actually use wind and solar. And of course, the mountains also have the potential to sequester carbon if we plant more trees and restore the grasslands, though there is an economic potential for actually addressing these kind of issues. There is, of course, still a potential decrease, and the decrease is if all the snow disappears, you have less snow and more variable conditions, then winter tourism will be very, very much constrained. And the mountains will provide, obviously, still a more healthy and pleasant environment for a wide range of new jobs and activities. So even if the snow disappears, the summer tourism is likely going to increase. But there will still be out migration in cities because most of the communities in the mountains are small, and for some reason or another, people like to be in big cities and be in the crowds. So those are my views of what is happening. Of course, this is all speculation, but it's something you need to think about. So tourism has a direct and an indirect impact on the resources because tourism not only affects the land, it affects air pollution and creates acid rain because in many of these mountain valleys, when all the tourists come in and all the traffic comes in, it creates a lot of air pollution. There also, because of tourism, more demand for snow, more demand for water, and more pollution. Also, if you have lots of tourism, you're compacting the soil, and that means you're going to get more runoff and more sediments. Of course, when you bring in all these people, you need far more energy, not only for transport, but also for all the other activities like skiing and so on. I'll show you some data on how much energy it takes to do all this recreational stuff. And then, of course, is the food security problem, because we already have a problem with food security in the mountains. When you bring all these tourists in, they have much higher demands, and often the local supply of food is insufficient, so we have to import food. And then, of course, if you have too much tourism, you also have an impact on the aquatic life and fish, because almost all tourist activities in the summer are related to water. And then, of course, you have the problem with the vegetation. If these trees are stressed by the air pollution or compaction from this and more climate change, you can have more wildfires and you lose biodiversity. So those are the direct and the indirect impacts of tourism on mountain resorts. This is what I call my horrendogram. This is just showing you the complexity of tourism and its impacts on water. You don't need to look at all these details, but it gives you an idea what tourism creates. It creates more wastewater. We need more water to supply them. We need more energy. Spas and swimming creates more demand for water and all kinds of products to keep you safe. Snowmaking takes lots of water, and of course, it creates more stormwater, which is particularly bad in mountains because if it runs down the mountainside, it creates erosion and affects everything downstream. So these are the activities which affect the water, and you can see it's a very complex situation. So it affects the hydrology, it affects the aquatic organism, and it impacts water quality. So if you look at the different mountain resort activities, skiing is a very big thing in the winter, hiking is a big thing in the summer, golfing is also very high in the summer, mountain biking now all of a sudden is becoming important, and of course swimming is important. And all these activities create all kinds of impacts on the water resources. Just to give you an idea, the importance of the European Alps. This is just showing you the number of visitors every year. So the Alpine region, which is France, Italy, Switzerland, Austria, gets almost 70 million people visiting every year, except last year and this year, of course. But they have to accommodate all these people, and they have about 660 major mountain resorts to do that. So the mountain landscape is changing by tourism in two ways. It is creating urbanization in the mountains. This is a Whistler in Canada where we had the Olympics, and you can see all the crowds, and everybody wants to have the same environment as they have in their cities from which they come from, and that creates all kinds of issues. And then, of course, we now are making a lot of snow in order to accommodate these people to make sure they can ski in the wintertime. So when you look at the economic issues, you want to operate in the wintertime, you need at least 100 to 120 days of secure snow conditions. And then, of course, in the summer, you also want to make sure that the climate conditions are reasonably good so that people will come. So the summer activities are these and the winter activities are these. And in order to accommodate these people and entertain them, they are now bringing in concerts and conferences and festivals and spas and health and shopping and everything else. So we're actually transforming the mountains into urban cities like in the lowland. What is particularly interesting to me is how the tourism has changed in the European Alps. Tourism actually, it's not a form of tourism, but people moved into the mountains in the 1890s and 1880s because it was the only safe place for tuberculosis. People had tuberculosis and we had no vaccine at the time. So they built these sanatoriums at high elevation where people could survive. And then when they finally solved the problem of the vaccine, the mountain climbers came in. So the very early part, people came into the mountains to climb the mountains. And then skiing started about 1920. Then the golf stuff and the hiking came in around 50. And then we have snow ski aerobatics and we have mountain biking. And now we're going back to the health situation. So in the early days, it was for health, and now they're advertising wellness, spas, and health. And climate change is also telling you want to go to the mountain because it's a more wealthy environment or healthy environment. So a very interesting a cycle where we started and now we're doing pretty much the same thing. So just to give you an idea, the size of densification and urbanization, you can see here, these are in the Swiss Alps. You can see about half of the people come in the winter and half come in the summer, depending on what resorts you look at. But basically, they're saying if you really want to be economically viable, you need two seasons. You can't just rely on the winter season. You need both. So in the past, we were protecting the climate and the snow by building all these different obstructions to hold back the snow so that we don't have too many avalanches. And now this is totally reversed. Now we are protecting the mountains to make sure we have enough snow. So there we had too much snow and now we have not enough snow. So now we're making snow. So just to give you an idea of the infrastructure which is being developed in order to maintain winter recreation. This is the town of Switzerland, and these are all the ski resorts and the trails and everything else. So you can see there's a huge infrastructure here. So I calculated, or I looked up all the data, and I was curious to see how many people can these different resorts move in 1 hour. So here are some different resort areas from Switzerland to the States to Austria to France and so on. So these are the number of people which they can move in 1 hour the resort areas. And so look at this. They can move 250,000 people in 1 hour in these resorts. This is probably equal, or in some cases more than in many of the city's transport system. So think about the energy it takes and think about the infrastructure it takes to actually do that. And so, of course, particularly in the wealthy countries, everybody wants to have their chalet. And here is the old traditional village. And you can see now a lot of new people come in and they want to have their winter chalet and summer chalet so they can do the mountain recreation. And that creates a complete new landscape, which creates all kinds of problems for water and runoff and everything else. So the number of ski resorts in Switzerland is 150. The elevation is greater than above 2,800 meter elevation. They have 3,400 kilometers of trails. This is like building roads all over the mountains. And even if you go to high elevation, like 3,000 meters, you still have over 200 kilometers. Whoops. So this is just showing you here the number of ski lifts and the number of runs and the length of all these runs, which is quite dramatic. So if you look at this, the number of skiing days, skiers per day is 22 million. The hiking trails are 12,000. The cycling trails are 12,000. And the mountain biking is 8,000. Well, the trail network, total trail network is in this kind of kilometer length. This is more than the distance across Canada, or in some cases, more than the distance from Russia, from one end to the other end of Russia. So we're building all these roads and trails and access systems, which have a huge impact on the environment and on the runoff. This is just the most interesting thing I came across. They built this railway which goes up here and then goes into the mountains and goes to the top of the mountains, and then you can actually visit the glacier, and this is known as the top of the Alps. So this is similar to Mount Everest, except in Mount Everest you have to hike and puff and huff and need oxygen to get to top. Here the railway, which was built, can actually take up anybody, no matter what age, to the top. So in 2018, before the virus, they had 1 million people who took the train to the top of the mountain to look at the glacier. And what is incredibly interesting to me is they have a station up there which measures all the climatic conditions, and they started measuring the CO2 some 15 years ago. And then 2 years ago or 3 years ago, they decided to put a second station on about 1 kilometer away from the lookout place to see what the variability is. And they found over the last 3 years, before the virus, they found that there was a slightly higher CO2 emission at the location where the train station is on top of the mountains. And they couldn't explain why there was a slightly higher CO2 emission at the train station versus on the glacier. And they figured out it's probably from smoking by tourism. Because if you get 1 million people coming up there, and the first thing many people do, they want to smoke. And this is an interesting thing. We can see how little it takes to change all this emission. So snow accumulation is really the most important thing for winter recreation, and I'm just showing you some examples on our part of the world in Canada. So in the past, we had a lot of snow accumulation in November, December, and January. This is when we have the peak, and then it drops. So currently, we're in the orange stage, and the future will likely show that we're going to be much, much lower. And in fact, here is some data which can show you that's in the 1950s in blue. We had that amount of snow in this particular ski area, and now 2000, 2010, we're already down here. So you're looking at about a third drop in the amount of snow. So they're saying if it is warming by 1, 2, or 4 degrees, right now they have about 660 ski resorts and about 600 now. This was earlier. And if it's a 1 degree change, we'll go down to about 500. If it's 2, we go down to 400. And if it's 4, it's going to go down to 200 resorts in the Alpine region. And this is interesting because we're already in this stage here, but they have been able to actually maintain many of these resorts because they're making snow. So for those of you who don't know German, this is the advertisement for one of these ski resorts in Switzerland. It means snow security for sure. So they're advertising and telling you, you can come and we make sure that you have snow to ski. And so they're building all these snow guns. There are 2 different types of snow guns. These go and spread the snow very far, and the other ones much less. So I calculated how much water and how much energy it takes for snowmaking. So if you want to cover 30 centimeters per hectare of snow, it takes about between 2,000 and 4,000 cubic meters of water to make the snow. So that's basically a half a cubic meter, which is 500 liters for 1 square meter of snow. So these snow guns are very expensive. Some of them cost $20,000, $30,000, depending on how fancy you want to get. And they're very, very sophisticated. They can actually make snow even now when the temperature is -1 or -2. But when you blow out all this snow, you put in the water and you blow it out in form of snow, you get a lot of sublimation. They estimate, depending on the humidity conditions, they estimate anywhere between 10% and 40% of the water which you use is not making snow, it's just coming back up in the atmosphere in terms of vapor. So when you look at these rates from 2004 to 4,000, this is equivalent to irrigating corn on a hectare basis. So we're now farming snow as we farm agriculture, and the energy requirements are huge. And depending on the gun type and the air temperature and the humidity, you can see the amount of kilowatt hours it takes to make this snow. So major ski areas anywhere in the world make snow. And this is true in the United States, it's true in Europe, it's true almost everywhere. I think probably 70% of all resorts now are making snow. This is 2 years ago. Major Swiss resorts, 35% are making snow. In Austria, it's 70%. In Italy, it's 80%. And in France, it's 60%. So most of them make snow. These are some of these snow guns. And you need water in order to do that. So what I'm showing you is a glimpse of the fieldwork area of IPROMO. This is in the Dolomites, and hopefully we'll get a chance to see this area. But the point I'm trying to make is they showed us that they created a very nice lake. It's a constructed lake and use that water to make snow. This is the purpose of the lake. The lake is created to have enough water in November so that they can make snow in late November so that they can open the ski area at Christmas, because that's when they make most of the money. We have lots of glaciers, and these glaciers are smelting. So now what they do, they're not only creating lakes to store the water for snowmaking, but they also cover some of the remaining glaciers with plastic during the summer to make sure they don't melt so fast. And so we've now gone from snow fences to collect snow by natural process of wind accumulation to snow making, and now we're moving to snow farming. And what I mean by snow farming is, in many of the resorts now, they make snow when it's cold enough and pile it up and then cover it either with plastic or sawdust and try to keep it over the summer and then use it in November, December to start a ski area so that they can open at Christmas. So this is a totally new activity and is very labor intensive, very expensive, and you lose about a third of the snow during the summer, even if with the best cooling systems and sawdust and plastic. So it takes lots of water to do this. In addition, we're obviously adding all kinds of chemicals in order to make the snow, like we add ammonium nitrate, potassium chloride, and all kinds of additional things to make sure we get the right type of snow. Some of these are pretty good. Ammonium nitrate is not bad because it's a fertilizer. Some of the other ones are not maybe that benign, and we really don't know what some of these problems will be. So this gives you an idea how much snow they are already accumulating in snow farming over the summer. So in France here, 20,000 cubic meters of snow is estimated to be produced and covered over the summer. In Davos, similar kind of levels. And then that takes lots of sawdust, which means you're gonna use a lot of trees in order to cover it, and so for snowmaking in Switzerland, 34% of the water for snowmaking comes from rivers. 30% is from drinking water, because you can't really use gray water to make snow because these machines are very sensitive to particles. So you need relatively clean water. So most of them use rivers which have little sediment in it. They use drinking water, some use springs, and some use lakes. So the big problem with snowmaking is, if you look at the river flow, we have very little river flow in January, February, March. And then when the snow melts, we get lots of stream flow. And then in August, when the summer is at its peak, or July when it's on the peak, you can see the river discharge drops dramatically. And then at this point in the history, we need to start making snow. That is one of the low parts of the river system. And this is when the ecology is stressed, because it's at the end of the summer, and that's when we need the water. So this is a huge concern for environmental services. So snow farming, and the impact of snow farming is as follows. It increases demand for water. It increases the hydropower. It has additives which create pollution, and also it creates more erosion, because we are compacting the soil. And Michele Frappas will tell you more about it because he's the expert on all this type of thing. And of course, that creates a lot of greenhouse gas for snowmaking because you need lots of pumps. And of course, it affects the hydrological cycle in terms of river extractions and so on. You also, of course, have to create a new form of infrastructure to protect all these communities in the lowlands. So you can see the access roads are in very precarious environments. And even here, when you can see the frequency of avalanche or the landslides or so on, they have to build these huge protective structures, which are quite expensive to do and to maintain. So water consumption in mountain communities is the demand in the wintertime when the rivers are low, and in the summertime, right at the end of the peak flow when the demand is greatest. So in the winter, a large number of skiers require snow, and the people who come actually use far more water than the people who live there, because they assume if you live in a city, everything is provided for you, and you probably will not change your habits when you go to the mountains. And then, of course, in the summer, it's not only the activities, but it's also the food, because people to eat the same amount of food, the same type and the same amount of food as they're used to in the city, which means you're going to have to import all this stuff. So I looked at some of the water consumption by tourists versus the water consumption by local residents. And in the wintertime, the water consumption is pretty much the same. But then as the summer progresses and you get lots of summer tourism, you can see this is the temperature. As the temperatures goes up, you're using more water, and this is the mean monthly water use. And you can see that the local residents, because they're much more aware of the water resource issues, they use far less water, and those which come in use far more water, particularly when it gets hot. So summer tourism also is an issue because it will affect the streams, the lakes, the springs, the reservoir, the groundwater, and because we do lots of swimming, spas, more domestic water use, and of course a lot of golf courses. So summer recreation activities are all mostly water-based. They use water and they impact water, and all of these activities have an impact. So consumption, domestic water use, and wastewater use increases dramatically as a result of tourism. I had an opportunity to work in the driest watershed in Canada, which is an area where we have both winter and summer tourism, and it's a vine growing area. And we discovered in the driest watershed in our part of the world, we have 54 golf courses. And the number of golf courses in the world is estimated at about 35,000. The mountain golf courses is estimated at about 5%, and the average size of a golf course is 30 hectares. So many major mountain ski resorts have golf courses for the summer in order to attract visitors. So claims are that we now have a competition if can you actually play golf in at the highest elevation anywhere in the world. So now you can see even in the Andes in Peru and Colombia and in the Himalayas and in China, they're now competing with the European Alps for people who want to actually play golf at these different elevations. So if you look at the 45 golf courses which I looked at in my part of the world, and how much water they use, you can see here is the water demand per cubic meters per year for these golf courses, depending on the size. This is the size, but on a hectare basis, they all use the same amount, but it's very, very high. It's actually higher than what we do in agriculture. And the interesting thing is here's this dry watershed, and these are all the golf courses, and this is the amount of water all these golf courses use. And so the average golf water course use is about 9,000 or almost 10,000 cubic meters per hectare. And they all over irrigate because for some reason or another, they're not very environmentally friendly. They want to have everything green. And usually the difference between a wet season and a dry season is somewhere like 30, we need about 30% more water during a dry summer than in a wet summer. So the average water use for crops is about 6,000 cubic meters per hectare. Well, if you look at this, this is far higher. So again, this is also a concern. And remember, they want everything to be perfectly manicured, so it takes energy. And they use quite a bit of pesticide because they want to make sure everything is the same type of grass. So that gives you a bit of an idea on the challenges of tourism in relation to water. And I want to just finish with the following. So this is the highest mountain in Europe, an elevation about 4,810 meters. Our Italian friends know this better than me because they work on this mountain. And so they estimate about 30,000 people want to attempt to reach the peak of the highest European mountain. That means about 400 people try to go up here every day. 60% of them get sick and fail to reach the peak. Around 100 are rescued every year by helicopter, and they have to move about 500 kilograms of trash by helicopters every week. A lot of people die. More dangerous, it's becoming more dangerous to climb because of climate change and permafrost melting. And they're now for the first time contemplating about setting limits on the number of people which they will allow to go up to these mountains. This is even worse in the Himalayas, as many of you who are from that part of the world know. Here is the successful climb since 1953, when the first people successfully climbed it. So in between that period, about 10,000 people have succeeded in meeting the top of Mount Everest, and about almost 25,000 have tried to get up there, and a lot of people died. So you can see the successful climbs and the unsuccessful climbs over time, and you can see the number of casualties. So this is a real concern now because the hazards are actually getting greater with climatic variability. And so I will close with this one. This is Whistler Resort in Canada, where we had the Olympics in 2010, and you can see the massive infrastructure. Here's the town. And so Whistler wanted to have the Olympics, and they said, we want to be green. So we want to show the world that we can actually do things in a very environmentally friendly way. So roughly these are the statistics. They have golf courses, they have ski runs and ski lifts and all so on. So the residential population is in blue, and so the Olympics was in 2010. So in 2009, they said, we want to be sustainable and we want to reduce consumptions and waste generation and energy use by 2020, and they set targets. They said, this is how much we want to reduce our emissions. So the blue is the residential population and the red is the population which serves the resort, you know, all the people who look after skiing and the rescue and everything else. So we're talking about 30,000 people living in the summer and in the winter in this resort. So remember, the Winter Olympics happened in 2010. So this is the number of visitors which came to this resort. So very few in 2009, and then the Olympics started, and we got far more. And then after the Olympic, it dropped, but subsequently, you can see populations have gone up, numbers have gone up. So right now, they get about 3.5 million visitors per year to this resort. So the idea was we're setting targets by 2020, which was last year. And so we were going to set targets for energy, for landfill waste, and for water consumption. And here is the results. So you can see in 2009, before the Olympics, we generated a lot of waste which went into landfills. And because of the Olympics, they actually were successful in reducing the landfill. And right after the Olympics, things were pretty good. They were much lower than before. But in the meantime, you can see things have gone up because we're getting more visitors. So the target which was set for 2020 is no way to be reached, except for the coronavirus. Because now, I don't have the data yet, but we haven't had any visitors this year, or very few visitors. And so now we actually met the target for landfill, and most likely will meet the market or the target for water use and energy use. So here's the blue is the water use, and you can see the water use is in 2017 and 18 was still higher than the target, and the energy use is about the same. However, the target for CO2 emission went down a few years, but because more visitors are coming in, we're not meeting that target. I don't know whether we actually will meet the target this year because of all the lack of visitors. However, the last thing which is important is we actually have a glacier on the top of the mountain, and the glacier is actually shrinking. So for the first time now, they are making snow on the glacier to kind of compensate to the fact that the glacier is melting fast, so they're trying to add more snow to extend the length of this growing season. So that needs to be considered as a very speculative kind of activity, because is this economically viable in the long run? So that gives you a bit of an idea of what tourism actually does on the water resources. And for those of you who have parkas, which advertise North Face, you will see a lot of people have parkas which say North Face. This is actually the North Face of the Eiger Mountain in Switzerland. And the Japanese are a lot of Japanese do a lot of winter sport and a lot of climbing. They test all their gear, all their equipment, be skis, parkas, climbing equipment. They test them here on the North Face, and this is why this is such a popular advertisement, and this is where it actually happens. So I'm happy to talk to answer a few questions if you have.
Okay, Hans, thank you very much for this first section of the day. There is a question from Pranab. How does one control the water pollution induced by chemicals used in snowmaking and snow farming, especially with melting of the snow when the water flows downstream?
Well, this is a very difficult thing to address because we don't know what some of the impacts are on the chemicals which they use. Some of them are probably not very important. Like I said, well, the fertilizer stuff, if you do it right, is probably okay, except if you have too much, you can create eutrophication, you're that blue-green algae stuff. But generally, that's not so important. The bacteria, they use some bacterial, and so far the bacterial problem has not been a big issue. But again, this is in the early stages, so we don't know too much about the long-term impact. What we know, which is more important, is we're compacting the soil, and that is going to change the vegetation in the summertime, and it's going to change the aquatic organism in the soil. So again, I'm not sure what they are actually applying in the snow farming business where they store the snow. Again, that's an area which we need a lot more research.
Okay, thank you so much. Another question from Piyush. What is the impact on biodiversity, especially in intensive use areas like the Alps?
Well, remember, the Alps are the hotspot for biodiversity, and the farming has changed that biodiversity somewhat, but they usually do, well, that's not exactly true. They have a lot of animals in the high mountains, and again, that changes the natural biodiversity. But they actually have a program to encourage the farmers not to fertilize some of these mountain grasslands. They give them a subsidy so that they can maintain or encourage the alpine flora to flourish. In Switzerland, a farmer gets a subsidy if he doesn't fertilize the grassland in the high mountains. And so again, that's an interesting kind of thing to maintain the alpine, oops, sorry, to maintain alpine biodiversity. However, the skiing stuff is really impacting the diversity because not only are you reducing the season, because remember you're adding snow and compact that snow in November, and then that snow melt because it's so compacted only melts later in the spring. So the growing season is going to be shorter. So in these areas where you have the snow trails, obviously that's going to affect your biodiversity. But all the experts are telling me that if we can actually encourage biodiversity by only changing our management of the mountains, but also by protecting many of these areas.
Okay, there is another question concerning biodiversity, and it's about the implication on artificial snow meltwater on biodiversity, which is the impact.
Artificial
snow melt.
Oh, yeah. The snow that we make is actually different from the natural snow because they want to have a certain grain size, which is best for skiing. And remember, they have now all these machines which kind of make your slope uniform, so it's easier to ski. And so the impact of that is not only the shortening of the growing season, but also the compaction of the soil. And so this obviously has a huge impact on what can grow afterwards. And usually they want to make sure that what is growing afterwards is grass, because they don't want trees to come through it. So again, that's what those are some of the issues.
Okay, thank you. Another question from Joao. This sounds to me that we will never reach that sustainability in tourism If a village who had that in mind couldn't reach the goals, what can we expect from all the other touristic resources where these aspects are not kept in mind?
Well, you're probably right. But
Unfortunately.
yeah, but you know what we need to start thinking about is benign tourism, you know, like ecotourism and stuff like, which means we're going to have to restrict the number of people in various places. And this is going to be a very difficult thing to do because it's economics. You know, if you build a resort area, that's very expensive. And so then when people, if not enough people come in, it's difficult to make money in mountains. So we now have a very interesting case. We have what I call the West Coast Trail. There's a trail on the coast of the ocean in Canada, in Vancouver, in the Vancouver area. It's a 30-kilometer hike along the wild coast. And there are no hotels, it's only a trail, and you have to pack in everything. Well, we now have set limits that only 30 people are allowed every day. And again, the impact of, and everybody has to take everything out. So this is probably a way where we can still maintain the biodiversity and the natural environment. And we need to start thinking about doing this in many other places. It's even happening now in Europe, in the big cities. Venice now has decided that they're going to limit the number of people who come in because the impact is too great. And that's going to happen in the mountains as well. And if we do this right, there is going to be a balance between the economics and the environment. And I think in some places we can do it. In other places, it's hopeless. You look at Mount Everest, and I don't know. I mean, even if they restrict it, the demand for crazy people to want to go to the top of the world is be continuous. And so even there, you know, all the problems about all the waste and all the sewage and all the oxygen tanks and all that kind of stuff.
Okay, thank you. There are many questions. I guess there is time for two more. Then we go to the break. I keep the other questions for the next question and answer time. Don't worry, every question will be answered. So first of all, are these activities have a long-term impact on Earth climate and what they are?
Well, this is going to be interesting because climate change is going to go much more rapidly than we thought, and we're going to be interested to see how the natural vegetation adapts to these new changes. Remember, the trees are moving very slowly up the high mountains because it's warming up. And a big challenge scientifically now is this is going to take nature will make this in a very slow process. However, we're now saying, well, maybe we should actually speed this up by helping this process and planting trees from lower elevation to higher elevation, particularly now when everybody says we need to grow trees to reduce all the problem from the emissions. Well, this is a huge dilemma where we're not totally sure what the right thing is. The very first thing you need to think about is what type of tree would you want to plant? Because the tree that you plant right now might not be the right tree in 50 years from now. In Canada, our growth rate of a tree is about 80 years. So what we're planting now might be the totally wrong tree in 2050 or 2070. So the only way we can do this properly is by thinking about biodiversity. If we want to help this process, we should plant a whole variety of trees, hoping that some of them will be the most appropriate one. But the big challenge is we want to grow trees which have economic values, and many of the biodiversity trees are not really the commercial ones. So again, this is a real challenge we are facing. So this is going to be a huge topic, very interesting topic, and keep your eyes open on what the best options are. I'm not a forester, so I can't tell you all the ideas, but maybe Giovanni, our Italian friends, can give you much more information on that. And remember, you'll get another presentation on tourism from the Alpine region, which is much more educational than mine.
Okay, thank you very much. We are going to the last questions of this first hour. Wister's case suggests that the growth has direct correlation with all the issues such as water use, energy use, CO2 emission, etc. Do you think that COVID has taught the industry people a good lesson and that they really walk the talk? Your example from Whistle area of failing to meet the target show that we will not lean unless major crises happen. And perhaps COVID is a blessing in disguise to build back better tourism.
Yes, because remember, energy demand is increasing at an incredible rate because we now want to convert everything into electricity. We're saying by 2030, all cars in many countries are supposed to be electric. So, and then if it gets hotter, everybody needs air conditioning. So the demand for electricity is going to go through the roof. And so tourism, which is very energy intensive, particularly in the mountains, they need energy from local sources because we have been exporting electricity from the mountains to the lowland. And we might even be now at the point where people are thinking exporting electricity from the lower part of the watershed to the higher part of the watershed in order to help the tourism. And the skiing business, like the snowmaking, is incredibly energy intensive. And so the main problem now is, can we actually use wind and solar in the mountains to actually help this process? And this is a very complicated question because you don't want to have huge solar farms in the mountains because this might actually create more heat for the snow situation. And remember, in the winter time when there's lots of snow, those solar panels don't work. I heard that in Switzerland now they even have solar panels on lakes, and so yeah, there is a possibility, but you have to be very careful when you think about alternative sources of energy, particularly in the mountains, because the climatic conditions are far more variable. And the wind, if you look at wind, the variability in wind conditions in mountains is much more dramatic than along the oceans, except, of course, in the hurricane channels.
Okay, thank you, Hans. Thank you very much. Now there's time for a short break, and we see you again in 5 minutes.
So our next presentation is on water pollution, and I put up these pictures to just show you how colorful water can be. So the main thing you need to remember is we are looking at water quality impact by activities from small to large, and water demand from low to high. So when you look at all the different activities, agriculture is the one which uses most of the water and also is the largest polluter of any land use activities we make in the world. That's followed by urbanization and mining and recreation and forestry. So forestry is relatively benign, but these two, urban and agriculture, are the real problems for all the pollution we create. This is my horrendogram to show you how urbanization impacts water. And I'm not going to go into the details, and I don't want to overwhelm you with all this, but I want to show you how complicated it is to deal with pollution. We got stormwater, domestic wastewater, industrial discharge, accidental spills, solid waste, atmospheric input. All of these create problems. So that's the urban impact. That's the agricultural impact. So we irrigate, we add chemicals, we have salinity, and so on and so on. And then we get forestry, where we create stream temperatures, sediments, nutrients, pesticides, and so on, depending on the activities. And then, of course, mining has a huge impact on water, because these are the different types of mining, and these are the different kind of pollutants which we generate. So these are all overwhelming kind of things. And the thing you need to remember, in every watershed, we have some urbanization, some agriculture, some forestry, and maybe some mining or tourism. So in the watershed, it's the cumulative effect of all these different activities. So when we look at water quantity and water quality, these are all the contaminants we have to deal with. We have to deal with pH problems, acidification, nutrients, endocrine disrupting substances, organic pollutants, pesticide, plastic, metals, pathogens, and of course, now we have to deal with the virus. I showed you this before, but I wanted to make sure you understand that when we deal with water quality, we always discover new issues. So in the last 2 or 5 years, plastic became, microplastic is the big problem. But now it's all the viruses. In fact, we have very little knowledge about the viruses to start with in water. And I'll show you some of the things which we're trying to do now. So there are many contaminants in nature. Some of the geological formations, like volcanic fissures and so on, they have all kinds of nasty chemicals which affect the water. So arsenic, radon, asbestos, metals like mercury, lead, and zinc, and copper, they're all being released when the water goes through them. If you have ever gone up to a volcano and you looked at the kind of stuff which comes out of a volcano, some of it is quite nasty. So when we look at the impact on health, what happens with a number of contaminants is it follows the blue line, which means this is the concentration and this is the health score. So what happens is this is healthy and this is bad. So most of the contaminants at low level, they are not really that bad. And then there comes a point, a concentration above which it becomes really bad. And then you can see so we regulate usually the contaminants at that level. But there's some contaminants which are linear. Arsenic, for example, is linear, which means there is no threshold. So even at very low concentration, this is a problem. And that's not only a problem for people, this is also a problem for organisms in the water. You can see at low level, it might be deficient. This is the optimum range. And if it gets too high, it's going to be toxic. So this is typical for metals. So arsenic is a problem everywhere in the world. Here's just some examples of ways, and it's mostly from underground geothermal activities and rock formations. Agriculture, which is the biggest contaminator, is mainly nutrients, excess nutrients, particularly from manure, fertilizer, pesticide, and so on, creating all these problems. It also creates a lot of organic matter from plowing and all that thing, which obviously creates turbidity. It also, particularly in the dry area, we create salinity, particularly if the water evaporates and then crusts form. We start to increase drainage so that we can operate better in the agricultural area. And when we drain a land, it allows the contaminants to move much faster into the water system. And when we compact the soil by heavy equipment, we allow more of the rainfall to run over the surface. And it's usually at the surface where we have most of these contaminants, because we apply pesticides or fertilizer or any kind of chemicals to the surface. We don't apply it to the subsurface. So here are all the problems, and here are all the impacts on water. So you don't need to read all of this because you will get access to all this information after the course, and you can do with it whatever you like. I did a calculation sometime. We have about 7.5 billion people, and we have about 3 billion livestock unit equivalent. That means I converted all the livestock, the pigs, the sheep, the goat, and everything into livestock units. And then I calculated that a human being produces about 4 kilograms of nitrogen per person per year, but a livestock unit produces about 30 to 40 kilograms of nitrogen in the waste per year. If you do this calculation, you end up with the waste from livestock is equivalent to 21 billion people in the world, and we only have 7.5 billion. So this gives you an idea that in agriculture, livestock is actually generating huge amounts of manure and nitrogen and phosphorus. The big problem is, this is worldwide, is when you have too many nutrients, you're going from oligotrophic to a eutrophic system. The blue-green algae take over. So most of the mountain lakes are oligotrophic. They have very low nutrient content, and obviously only certain species can live in this environment. Excuse me. And as soon as you add nutrients, you create a better, more productive environment. But if you go too high, you create all these problems. So in order to deal with the nutrients, we need to start looking at nutrient budgets, and particularly the budget for nitrogen and the budget for phosphorus. So these are the things you need to calculate when you want to look at sustainable development in terms of application of fertilizers in all the agricultural activity. Typical nitrogen and phosphorus, which creates all this eutrophication, come from point and non-point sources, but it's not only agriculture. You can see urban runoff has quite a bit of these nutrients in it, livestock, even air pollution, long-distance air pollution, because we create a lot of dust which has nutrients in it. Forestry, agriculture, untreated wastewater, and treated wastewater, all of these have nutrient impacts. Probably the most important one is nitrate, because we have a very interesting classification. We say that 10 milligrams of nitrate in your water is the safety standard. Above 10 milligrams, young people less than 1 year of age have no capacity to actually break down the nitrate. And so they're saying we should never have drinking water which is above 10 milligrams per liter. Nature, almost all water in nature which is unaffected by human activity, is anywhere between 0 and 3. So you can actually look at nitrate in terms of what's the impact of land use activities. As long as we're down here, we're probably okay. But if we get up here, this is of concern. And if we are here, this is of serious concern because it creates this blue baby syndrome. So if you look at the water in my watershed, and you can see the privilege you have when you have lots of graduate students, you put them into the watershed and they do a master's thesis or a PhD thesis for 2-3 years, and then a 5 year or 10 years later you have another student, and then you have another student, and you have another student. So the green is a watershed which is adjacent to this agricultural watershed, which is in forestry, and this has not changed over time, whereas these on agriculture have increased dramatically, and you can see the kind of increases we have by agricultural intensification. So these are the kind of problems with eutrophication, and you can see this in lakes and rivers and everywhere. And here are some of the options we can deal with. We can have nutrient budgets, so we can say, let's only apply enough nutrients to maintain the vegetation and have no surplus. We have to move manure from surplus areas to deficit areas, because if you look at the kind of livestock production, if it's in the mountains and it is dispersed, it's not a problem. But we have densified all these livestock operations, where in many lower parts of the world, they're all in factories. We need far more precision fertilization. We need to store the manure and only apply it at the appropriate time, because if you apply it just before a rainstorm, that creates all kinds of problems. We need to determine how we can absorb excess phosphorus in the soil rather than having it to go into the water supply. We need to start thinking about stocking density. In other words, looking at what is the carrying capacity of number of animals per hectare. And then, of course, we're now at the point where we're saying we are treating human waste in these very intensive livestock operations. We need to start having treatment facilities for manure and not just think it's a good fertilizer. We have livestock intensive operation in Alberta where they have 80,000 animals which they feed. So you can see this is like an urban environment creating all kinds of problems. So maintaining water quality, we need to minimize eutrophication, minimize salinity, minimize pathogens, which is now becoming really important, minimize turbidity, and avoid arsenic deposition. Here is a watershed in the middle of our city, and there's a lake. And we wanted to see what the impact of urbanization is on this lake over historic times. So we cored the lake because every year during the spring period you get a layer of sediment, and you can actually look at what are the metal content of these sediments using isotope analysis. So you can see this is the amount of sediment which came in, and these are always periods when we had big storms which created a big layer of sediment. And then with the isotope analysis, we can look at what was the contamination down here and what's the contamination here and there. So we were able to show that the lower sediment was deposited about 1780. Now, in this part of the city didn't exist until about 1880. This is when the city started. So we can look at what was the human impact since the city was created. So when you look at this is lead, copper, and zinc. You can see when nobody was there, we had nothing. And then people started moving in, and then people had cars, and we had lead in gasoline, and it went sky high. And then we abandoned the lead in the gasoline, and you can see we're now going down. However, if you look at zinc, we're still going up. And zinc is really the source of most car tires because that hardens the rubber, and we have more traffic, and so you can see the zinc levels are still going up. What is even more important, we used DDT in the 1950s and 60s. And you can see we still have DDT in the sediments of the historic times. And that means if you now want to rehabilitate that lake, you should not disturb the sediment in the lake, otherwise you're going to create even more problems. So that's about agriculture. This is about mining. Mining is restricted to very small areas, but has a significant impact on not only sediment generation, but also on the discharge of all these metals and other things into the river. Even if you have an abandoned mine, that can still, after many, many years, have huge impacts on the water system. The biggest problem with the metal mining is acid mine generation. What happens is most of the metals which we use, like copper, zinc, cadmium, and so on, they're in the sulfide form. So it's a metal sulfide, and if it's under reducing conditions, it's very stable. But as soon as it gets into the air with oxygen, it oxidizes and creates sulfuric acid. So I'm showing you all the places where we have metal mines in Canada, and where some of these metal mines have acid mine generation. So almost all the metals, copper, zinc, lead, and so on, are in the sulfide form, and once you dig them up and have them exposed to the air, you can see what happens. You get this acid mine coming out. In this case, the surrounding environment is limestone. So as this acid mine water, which is very low in pH, gets into the river, and the river is actually alkaline because of the limestone, you get this chemical interaction, which is quite dramatic. So you can actually trace where your acidity comes from by simply looking at your watershed and look at the pH. So in this watershed, the pHs on the surrounding areas were all very high in the alkaline range. And in these three tributaries, they were acidic, so you know this is where the acid mine discharge is coming from. So the other big problem now is fracking, because fracking is a very water-intensive activity, and they use huge amounts of chemicals in order to do that. So what they do is they drill into the subsurface and then make a 90-degree shift and go horizontally for several kilometers, and then they put in high pressure water with sand and chemicals to break and make cracks in the formation to release the gas and the oil. So in order to do that, they need lots of water, and they use all kinds of chemicals, and they recover only about a third of that water, and the rest is probably going to groundwater. So I'm just showing you here, there's one of these operations. These are some of the chemicals which they use in order to do that, and they're actually quite nasty. Some of them are actually carcinogenic. So this is a huge concern for people involved in the groundwater business. The Atacama Desert in Chile is an interesting place. We worked there for about 5 years in the very high elevation. They have these kind of deposits which are now probably in greatest demand of any other mineral. Lithium. And lithium is going to be used for almost all the car batteries and so on. So again, this is an interesting environment. In fact, in the same area in the 1900s, they also had lots of nitrate. So this became the fertilizer of the world in the 1900s. And now this is becoming the battery of the world because of the lithium. And again, the impact of that on water is quite of concern. So for groundwater, the typical groundwater contaminants are nitrates, as I mentioned before, but also pathogens, salt and arsenic and hydrocarbon. So that gets me to pathogens. And this is important now because for the first time, we are actually looking at not only the big pathogens like the microbes, but we're also looking at the viruses. Until very recently, very few people have actually looked at viruses. The only research which has been done was in big ocean ships, because what happens with ships on the ocean, they take on cargo, let's say in Singapore or in Hong Kong or wherever, and in order to stabilize the boat, they have bulk water to stabilize the thing. So they might take on water in Hong Kong to stabilize the boat. And then they go to maybe Rotterdam or Vancouver or wherever, and then they change the cargo, and then they have to release some of that bulk water and then add new bulk water from the local area. So most of the studies on viruses have actually been done on this part of the activities, and they found there are billions of viruses, and we only know about 5% of what these viruses are, and we know even less what they do. So our knowledge of pathogen has mostly been on microorganisms, not viruses. And we are looking at waterborne infection type of things, water-associated infection, and pure sanitation infection. Those are the sources of all the contaminants in water. So the common problems are bacteria and viral infection, and here are some of the waterborne, the water-associated ones, and those which don't need water but can actually give you all kinds of nasty things from associated things. And then the parasitic ones, they're obviously the ones which we have to deal with, particularly in drinking water. Almost everywhere you go, there is some Giardia or Cryptosporidium, and these are kind of pathogens which are not very nice because they make you really sick. Now comes the coronavirus. And now the big question is, can it actually survive in water? We know that it is in droplets when we breathe. And we now know that a number of people are actually looking at the sewage water to determine whether the virus is in the city. So in many parts of the various cities in the world, they're actually trying to trace the virus in the city water from the sewage to make sure we know it's there, and then we work backwards to see what the infestation problems are. So the question is, how long will it survive in water? And for right now, the knowledge means maybe a few days or maybe a few weeks, but we're not totally sure yet. If we treat the water, is it safe? So far, yes. There is no evidence that once the water is treated that it can be transmitted. Heat, high heat, and low pH, and chlorination, and sunlight, and other disinfection facilitate the die-off. So these kind of conditions actually help to reduce the virus problem. In natural water, wait and see. I'm not sure. Like I said, we detect it in sewage, and we can actually determine whether it's present in your community. So how do we prevent all this, particularly in drinking water? Well, we have to protect the surface and the groundwater and eliminate all the manure and all the feces which occur from livestock and wildlife and everything else. So our things are basically membrane filtration, sand filters, UV, and chlorination. There is no one water treatment which will provide you with safe drinking water. We are now talking about a multi-barrier approach. You need several things to provide you with safe water. For example, chlorination gets rid of most of it except Cryptosporidium and Giardia. So to get rid of crypto and Giardia, you need UV. And then if you filter the whole thing, you can also get rid of many other things. Almost if you want to have safe water, you need more than one type of treatment. And to prevent this, you need to start looking at all the insects. And as Danilo mentioned, maybe we should try to actually eat some of these. Nature does, the birds and so on do quite a good job in reducing these kind of infestations. So the prevention of infection is dealing with poor sanitation. So washing, as you have now learned, washing your hands and washing everything is a very important part. So if you look at all the resistance of the different pathogens, you can see there are all kinds of pathogens around. Some of them have long survival, some have short, moderate, and some have low survival. Some are resistant, some are highly infectious, some have high significance. So this is a totally new world where we have to pay much more attention. And so I was involved in a genomic assessment of pathogens a couple of years ago, and I know nothing about microbiology, so I had a steep learning curve. They wanted to do it in a watershed basis because the biggest problem for all the health agencies is to provide you with safe drinking water. We test the water. And if there is an infectious problem, we tell them, don't drink the water or boil the water to be safe. And then we hope the pathogens will disappear. Well, if we don't know where these pathogens come from, we cannot prevent this problem. So in other words, if you get a Giardia problem in your drinking water, we want to know where that Giardia comes from. And so we need to start looking at the watershed and say, where is the Giardia source? Well, can we actually get to the point where we can say, this animal produces this type of virus or this type of pathogen? So like in the coronavirus situation, the bats are most likely the source of the pathogen, the virus, and so we could actually go and look at the bats and restrict their source of water or something like that. So in our case, we were kind of interested in saying what kind of pathogens originate from the different animals in the watershed. And in order to do that, you can use genomics. So I am now an expert in collecting scat samples. This is not a very pleasant job, but we collected all these scat samples from all these different animals, and then we looked at what kind of pathogens do they contain, and then we said, are there certain pathogens which are specific to alpaca or chickens or whatever, and then we can go, if we have an infection, contamination in the drinking water, can we actually go into the watershed and prevent it from going in? So here is the the genome analysis, and we were able to actually identify that 2 of the pathogens in our drinking water in that watershed came from sheep. So we now can regulate the sheep from preventing the problems to get into the drinking water. This is the most important slides from the pathogen perspective. Do you know about biofilm? You know, when you go to the dentist, they scrape your teeth because there is what we call a biofilm, a liquid biofilm around your teeth. And the biofilm is where all the bacteria can actually hide. So next time you go into a river, pick up a rock. When you pick up the rock, the surface of the rock is a bit slimy. That slime is what we call biofilm. It's an organic kind of snot. And the pathogens can actually hide in there and survive until they get disturbed, and then they become active. And so we now know that when you look at organisms in river, in the clear water, there are relatively few organisms. In the turbid water, there are millions of organisms. In the sediment below, there are only about 1 million, so it's in the turbid water where you get most of the problems. So if we can prevent turbidity in your drinking water, this is a huge reduction in the problems of pathogen infestation. So when you look at drinking water sources, we need to protect the drinking water in different sources. Rivers and stream, if you get your water from there, the protection and source protection is different from groundwater or from springs or from reservoirs or from rainwater harvesting. A lot of people now, and I'll show you this in the next presentation, collect roof water for outdoor purposes, and in some cases now, in a very dry area, they collect roof water for drinking water purposes. And these have to be treated very differently from this or that or that or that. So we need to start monitoring all these water pollutants, and monitoring is a very difficult task because it's not just monitoring the water. You need to monitor the land use, the water. You need to monitor the physical part like the sediments. You need to monitor the habitat, the chemicals, the biology, and of course the social stuff. And so monitoring is a real challenge, and I will show you how the community efforts can now help in this monitoring business. So when you look at water pollution and pathogens, think of it in a watershed context, because different contaminants start in the headwater from the ones as you go down into the river basin. So this is the headwater and this is the mouth, and you can already see the differences, and you need to start looking at not only the water quality, but you need to know the water quantity, because you need to know how much water is coming down so you can actually measure the load. And then you also have to look at the sediment, because sediments absorb not only pathogens, they absorb a lot of other things like metals. And now what we're doing is we're actually looking at organisms like invertebrates as a policeman to show what the pollution is. So invertebrates are usually benign in that they don't move very far. So when you collect certain invertebrates in one part of your watershed, they are pretty much stationary. They only move a few hundred meters, and that means they're the policemen and they can tell you what the problems are at the local level. So if you look at invertebrates at the high level in the watershed, at the middle part and at the lower part, you can actually see whether the biodiversity is good. That means the water is good, and if the biodiversity is low, then the water is not good. So that's a new way of looking at water quality. So again, in summary, let's look at the problems with water contamination and some of the solutions. So the health regulations are focused on single contaminants, and we need to now start looking at how can we control the source of these contaminants and restrict some of these activities, as I mentioned, with the sheep. Cumulative effects of contaminants are much more important because we virtually have no regulations on the combined impact of contaminants. If you look at our regulations, we have regulations for nitrate, for metals, for mercury, for zinc, for all for single contaminants. But if you're a fish, you're exposed to a whole range of things from pathogens. The whole soup is there. And so the cumulative effects are much more difficult to regulate. And so we need to look at how do we use natural processes to protect for these cumulative effects. It's very difficult to determine short-term. It's difficult to determine the short-term effects versus the long-term effects. This is particularly now popular with the virus because we don't know what the long-term effects are. So there are all kinds of technical options, multiple barriers, and so on. New emerging contaminants, lots of discussions about viruses, pharmaceuticals and organics, and regulation are mostly for human health, but we need to start looking at regulations for aquatic health. And the main problem is we not only need to protect the source, but we also need to improve the way we treat things. When you look around the world, our wastewater treatment is getting very little attention. We pay far more attention to provide you with absolute safe drinking water. That's where all the money and the effort goes. And then the wastewater treatment is not very good in most cities. In Vancouver, which is supposed to be a nice, green, healthy city, we only treat the sewage in primary and secondary treatment. We do not treat them for all the nutrients and the contaminants which are discarded into the river and into the ocean, and we hope nature will cope with that. So we need to pay far more attention now to not only protect the source, but also to treat the source. So time for questions.
Thank you very much.
You're totally exhausted, eh?
Okay, Hans, thank you very much. Plenty of questions. So first of all, we have to go back to the first part because we have two questions left. Well, the first one from Piyush. Can the Bhutan model of high-end tourism serve other parts?
I didn't hear you.
I read it again. Can the Bhutan model of high-end tourism serve other parts?
I'm sorry, we have a bit of a microphone problem.
Okay, again.
Say it again.
Yes, no problem. Can the Bhutan model of high-end tourism serve other parts?
Oh, yeah. Well, I was very, very fortunate to actually work in Bhutan for about 3 years. And I am very impressed with what they're doing there. However, they have a relatively low population, and they did some very interesting things which I really admire, in that, first of all, they decided to progress at a much slower rate. We are in the mode of progressing as fast as possible and developing as fast as possible. And they decided to take the slow approach and try to be friendly with nature. And so they protected most of the forest. If you go from Nepal to Bhutan and you look at the forest, you can almost know when you are in the different countries because they protected about 70 or 80% of the forest. Well, that is not possible anywhere else in the world because we didn't protect things very well. So now we have to actually start rehabilitating some of these mountain habitats. And if you look at the history, particularly of the European Alps, there's been massive changes in the mountain environment over time and so on. And we now are at the stage in history where we're talking about mimicking nature, meaning we're looking more and more at using natural processes rather than the engineering approach. So I'm not sure the Bhutanese example can be applied very well anywhere else, but certainly we can learn certain parts of what they have done and helping re-establish a much more benign environment in the mountains.
Okay, another questions. The question is, what are the impacts to the environment that make the Canadian government to limit the number of hikers every day to 30?
Well, source control is probably the best way. And the source control really represents the following. If you get water from rivers, make sure you got a very nice vegetated buffer zone, which consists of grasses, trees, shrub, and so on. And that buffer zone should be fairly wide. So whatever runs off over the surface or goes through the soil and seeps into the river has a chance to be retained. So that is a measure which we can use everywhere to protect the river water source. When it comes to groundwater, you have to use a totally different way of protecting your groundwater source because that is what we apply from the top on the soil. And so there we need to start minimizing the amount of material and chemicals and nutrients which we apply to make sure that the organisms in the soil can actually cope. Remember, we have more organisms in soil than anywhere else. In fact, we only know about 10% of the soil organisms, and these organisms actually take care of almost all different types of waste. And so if we can maintain the biodiversity in the soil, we can prevent a lot of these kind of problems. So for groundwater, it's a different story. For rivers, it's a different story. And then for the other kind of things I will talk to you about in terms of stormwater management.
Okay, thank you so much. Moving to the next topic. Briefly, what can be the most suitable short as well long-term approach to treat AMD in high altitude areas?
In high latitude areas?
In high altitude.
Okay. Okay, now the one problem in high altitudes is because it's usually very cold and organisms function best with higher temperatures. So pathogen problems are much more pronounced in warmer climates than in cold climates. And similarly, when you look at your mountain lakes are very interesting environments because in most mountain lakes, they have low nutrients and low production capacity, which means you don't have the diversity of things as you do in warmer climates. And that means you've got a very unique biodiversity. If you now have all kinds of atmospheric deposition from long distance, either from fires or from winds which pick up pollutants, then you can actually enrich these lakes. And then you change the biodiversity of the organisms in the lake. And this is now becoming a huge concern. Some of you probably know that sometimes the European Alps, the snow gets yellow or orange. Those are deposits from the Sahara during windstorms. And these bring in all kinds of new nutrients and new conditions, as well as pathogens. So in terms of high elevation, if you don't have too many people and too many livestock, the water is usually very safe. You know, I remember hiking in many parts of the world in the high water. They never have to worry about drinking the water because the organisms are few. But as soon as you bring in all these other things like livestock and people, you're bringing in viruses and everything else. And then the new thing now with this long distance transport is showing you that we're actually bringing in other things. So protecting the water in the high elevation is becoming a bit more challenging. It's still much less traumatic than in other parts of the world. I don't know whether this addressed your question properly.
Okay, there are similar questions. As we know, nitrogen level of Earth cryosphere is reaching the limit. What is the solution? What could be the solution?
Well, I think we all need to change the way we eat, and we need to change our expectations. You know, if you're as old as I am, you get very impatient because you know that we're not going in the right direction. And so all I can propose is local actions. I don't think I can change the world, but I can actually make a difference at the local level. So if you are in a mountain village or in a mountain area, go and put as much effort into biodiversity, in minimizing consumption, reducing impacts both on the land and the water, and be more moderated in terms of your consumption. I think consumption is the biggest problem. And my view is fashion is the absolute worst thing we have ever come up with, because fashion tells you have to change everything every year, which is the most consumptive type of thing. And then you only keep it for 1 year, and then you create all the problems. So as individuals, I think you can do a lot at the local level. And if we get the young generation to actually move in the same direction as they now are, I am quite hopeful that we can make a difference. And you guys, this is the reason why I try to help you guys in this workshop. You guys are the leaders in this transformation, and you're going to make the difference of all the things we screwed up. So I'm encouraging you to be positive rather than worry about all the future.
Okay, another question. What wastewater treatment system would you recommend for mountainous areas in developing countries?
Yeah, this is a very important topic because I'm dealing with this on a regular basis because we have a lot of indigenous communities in Canada, and they live out in nowhere, you know, in a very wild area, and they're very small communities, and they all have problems with drinking water quality. And so the big challenge is, what is the most appropriate water treatment system for drinking water and sewage for very small communities who cannot afford all these really fancy systems like microfiltrations and membrane filtration and all that kind of stuff which we do in the city. So we were proposing a lot of sand filters which are relatively easy to operate, and they are actually quite effective with treating the water, and then have a secondary and tertiary way of treating it after it comes through the sand filter. But the problem is we have now told the public in general that this is not sufficient because this is third world type of approach. So now they all demand membrane filtration systems, which are supposed to be the state of the art. But membrane systems are extremely expensive and they take a lot of skills to manage because they have to be, the filters get clogged and they have to be backwashed about every second day. And so this takes a lot of training and a lot of effort, and it's extremely expensive. And so the perception now is sand filters aren't good enough. We need to have the more sophisticated technology. And in my view, I think some of the more natural systems can do a fairly good job with dealing not with everything, but with most of the problems. And trying to get that perception back is a very difficult thing because people now believe in technology can solve all this problem, but some of these natural systems can actually help you much better. So many of the sand filters, in addition to some other things, can actually be quite useful for very local conditions.
Okay, thank you very much. Or there is a comment concerning the Indian Himalaya region and the issues concerning the management of solid waste and hiking and camping tourism and all the work to make these people responsible, and it's very, very difficult to. There is then a question. Sorry, please.
Yeah, you know the problem on Mount Everest with the sewage. It is an incredible problem because you got so many people coming up there and there's no, well, very little facility. So they built these holes and then hopefully nature will take care of it. And now they even ask some of the Sherpas to actually collect every few weeks some of the waste in these facilities they have created and carry it down to a treatment facility. This is just unbelievable. And the big problem is if you have this kind of intensive waste generation in the headwaters, you're going to have all the problems below because many of these things can survive over long distances. And so we need to really start thinking about the tourism part is a particular problem. How do we treat things to high standards in the headwaters so that we don't create the problem even further down the road? So yeah, the Himalayas is a real problem because you are the source of the water for millions and millions of people downstream. So the more you can protect, the more benign it is for everybody else below.
Okay, last question before a 10 minutes break. If the natural lake is going to be eutrophic, is the only installation of aeration plant is enough to treat it, or we have to take other measures also?
This is a very, very clever question because we now have knowledge about how do we rehabilitate a eutrophic lake. And it is incredibly time consuming, it is incredibly difficult, and it takes a very long time. Creating eutrophication can be done extremely fast. I worked in China some years ago, and there was a big mountain lake, and within 3 years, the lake became completely eutrophic because the city on the lake had no treatment. Then we looked at a number of cases where they had a lake completely eutrophic and then they tried to rehabilitate it back to a mesotrophic state. Well, you need to do the following thing to do that. First of all, you need to control what is coming in. So you need to reduce the source, like the number of animals and the waste. Secondly, you need to aerate. that's not sufficient, because you also will have a lot, you have to skim off all the blue-green algae from the top. And then you also need to remove the sediment, because under long-term conditions, the sediments have absorbed a lot of the phosphorus, and under reducing conditions over time, it actually will release the phosphorus in an active form. So, and then you have to start looking at fish. You have to introduce new fish who can tolerate these conditions, and they can actually help. And then you can actually look at plants which you can introduce, which also help you in the rehabilitation, because they take up the nutrients. So it is an expensive process. It takes a lot of energy and a lot of time. If you're interested, there is a very good case study from the Lake of Sempach in Switzerland, where they had complete eutrophication in the 50s, and it took them about 15 years to get it back to a mesotrophic state where it's now reasonably good.
Okay. Thank you very much, Hans, for all the explanation and your answers. Okay, now we have a 10-minute break, and then we go back for the rest of the day. See you in 10 minutes, please.
Okay, this one is a little longer, so give me an extra 5 minutes. But I promise I will cut the last one to give time for your visitor. So now we've been talking about all the problems. Now let's look at some of the things we can actually do. And I'm going to focus on urban stormwater, because many cities anywhere in the mountains are dealing with all kinds of flooding. And so remember, people are still moving into cities. So if you look at this, this is the amount of people in the rural environment. We're now about 55% rural, 55% urban, and they're expecting people to become about 70% urban, even in the mountains. So there are many cities in the high mountains, particularly in South America. Here is the elevation, and here is the number of people. You can see like Mexico City and Bogota and La Paz. There are millions of people living in the mountains. This is La Paz itself, which is a very interesting one, because El Alto is the high elevation part of the city, which is very cold and miserable in the winter, and all the poor people live up there, and all the rich people live in the lower part where it's a little bit better. But the main thing is, whenever it floods, the poor people are okay, but the rich people get flooded. So this is an interesting thing. So not only do we have to deal with all the urbanization, but also the visitors. So typically, urbanization is expanding. This is the change which has happened in one watershed in urbanization in 11 years, from 84 to 96. You can see this was all forested, and within 10 years, you create all these what we call impervious surfaces. So we can actually measure the impervious surfaces from satellite imagery or LiDAR or whatever, and you can determine how much of your surface does not allow the water to infiltrate. So typically what happens in urbanization, if you have a natural watershed, the rain starts and then continues. That means the river will respond in this way. The rain starts, and if an hour or 2 hours or 3 hours, the water gets into the river and you get a peak flow. When you now make all these surfaces impervious, this is what happens in the urban environment. It means when the rain starts, the runoff will go directly in the stream much faster, so the peak is much faster, and it's much higher because none of the water is infiltrated or retained. So keep that in mind. In addition, this is probably the best example I can show you. This is what happens to rainfall. The rainfall can either evaporate in green, it can run off the surface, it can go into the soil, or it can go into groundwater. This is what happens in a forest. When you then convert the forest into a complete urban environment, look at the red part. So the more impervious surface you create, the more runoff you generate, the more flooding you're going to have. You probably never looked at parking lots in cities. This is where your engine is parked. And all of these kind of things, whenever it rains, they go into the water. And the interesting thing is, usually the first 15 minutes of a storm event has the highest concentration of pollutants, and after that it's usually reduced in amount of pollution. It's diluted. So what we are doing to the native environment, the aquatic environment, we're stressing that environment over a short period of time, and then it's okay again. That is more destructive than having a continuous increase in pollution. So these are all the different types of pollutants which come off the surfaces. So what we are advocating now in the city is to look at the property, the individual property, the neighborhood, watershed, the three different scales. This one deals with the light precipitation end, this with the heavy, and this with the big. So we're looking at scales in a different way. We say at the property side, traditionally what we have done is we pipe everything away from the property because you don't want your house to get, or your basement to get flooded. But now we're saying maybe we should try to retain more water on the site. And I'll show you how we want to do that. In the neighborhood, we actually drain and remove and pipe the water away the same way. Particularly, you don't want to drive on a road which is flooded. So we have all these drainage systems from the road and parking lots to move things away. And now we're saying, could we actually store much of that water and delay how we release it to the environment? And then when it gets to the watershed, we need to start thinking about storing the runoff, detaining it. Not in the past, we have channelized everything. We have protected all the structures, and now we say we actually need to do things totally differently, and I'll show you why. So this is what you can do at the property scale. If you own a house and you have a little bit of space, you can actually start thinking about a green roof, which can absorb some of the rainfall. You can think about roof water harvesting and reuse that water in the summer. You can minimize the impervious surfaces by all kinds of ways. You can even look at pavement which is pervious, which allows the water to go into the soil. If you have a garden, you could actually add topsoil so that the water can store in the soil. Remember, there is more water stored in the soil than in all rivers in the world. People don't realize that. And then if you have lots of trees in the urban environment, not only helps it with CO2, but it also absorbs and evapotranspires part of the precipitation, and it slows down the precipitation before it reaches the ground and the river. So that's what you can do at the property scale. Now, when we go to the neighborhood scale, then we have to deal with roads and infrastructure and parking lots and all that. So we're talking about, can we create smaller roads with no curbs and no pipes and no gutters? Can we actually build swales on the side of the road, which are sand filters, which allow the water to go in, the contaminants to be contained, and it will slowly release that water into the local stream? Can we actually build wetlands to detain some of the water and store it and also absorb carbon? Can we create a lot of pervious pavement which allows the water to penetrate? And what are some of the innovative ways of building parking lots? And then at the watershed scale, large buffer zones along the river so that some of that water can be absorbed, and you can put wetlands in the buffer zone, diversify the stream channel rather than channelizing it, use land use restrictions, and a complete new way of dealing with the floodplain management floods. So this is La Paz. You can see the poor people live up here and the rich down here, and all the problems is distributed. So some people have green roofs. That's a way to actually improve your heating and cooling system, and also absorbs quite a bit of the rainfall. Here is one in Vancouver where we are looking at helping not only to retain the water, but also improving the air pollution, because the deposits, which might be rich in nutrients, can help the vegetation to grow. You could actually collect the roof water and collect it either on the ground or store it in containers, or infiltrate it into the soil from your roof rather than having it piped directly into the stream. These are some of the roof water collection systems. I have 2 of these for my garden, and I never use domestic water, which is highly treated. Even in the industrial area, you can actually collect the roof water, and you can use it for outdoor purposes, or you can use it for flushing toilets, or you can use it for drinking water if you treat it in a proper manner. You can see the different things. This person here has 2 of these containers. One is for outdoor use, the other one is to flush toilets. Here is what we should be doing about pervious pavement. We tend to build everything impervious. We want to drive into it without having to get your boots wet. And so we create all these impervious surfaces which just increase the runoff. So why not do something like this, where not only can the water infiltrate in between here, but where is your engine parked? Your engine is parked right here, and all the contaminants from your engine goes into the soil, and the soil organisms can actually reduce some of these contaminants. Topsoil is a very important thing. What I'm showing you here is, if you have some lawns, some grass, if you would put 30 centimeters of topsoil there, you wouldn't need to irrigate during the summer in many parts of the world. If you only have 10 or 20 centimeters of topsoil, you can see this was never irrigated in the summer. This was, both of them are never irrigated in the summer. And you can see this doesn't do very well because it can't store a lot of water. We now have a regulation in town that every new house have to have 30 centimeters of topsoil built before they put in a lawn or a garden, and this stores a huge amounts of water. Trees intercept a lot of water. We did a study in our part. The part of the city has lots of trees, and we wanted to know how much water is actually evapotranspired by the trees. And lo and behold, some of these trees can evapotranspire between 30 and 60% of all the water which comes in by precipitation. So in a forest, a typical forest evapotranspires about 25 to 35% of the precipitation. However, urban trees are very different because, first of all, they're open, they're warmer, they have the wind going through it, they can actually evapotranspire more, and then they can absorb carbon. So urban trees are not only good for improving your quality of the air and the CO2, they can also help tremendously in urban stormwater runoff. Just to show you how much they can intercept, here's an example when it snowed. They intercept a lot of snow, and then that snow evapotranspires and sublimates and creates less water going into the surface and runs off into the river. We can have rain gardens rather than having a regular garden. You have a garden where the water can actually infiltrate. So in a neighborhood, what here is a plot which they're developing for a house. So what you could do is build a rock pit. This is a 2 by 2 by 2 meter hole where you put in rocks, and all the runoff from your impervious surface and your roof goes into this rock pit. It is slowed down, and then you build a sand filter on the side, which means that water in the rock pit will eventually seep through here. And then below that, you build a bit of a detention system before you release it to the river. So during very big storms, you can actually absorb the sediment and the amount of water which goes into the stream, which creates flooding below. So let me see what happens everywhere in the world. People want bigger houses and they want more impervious surfaces. So here's an old house. It was subdivided and goes into these new houses. How much impervious surface has changed from the old house to the new house? So if you look at this, in the old house had 23% imperviousness, the new houses have 54. That means you now have more water can no longer infiltrate, and it's going to run off and create more floods. So we're now building streets in the neighborhood where rather than having a manhole which drains everything into pipes and rivers, we say, why don't we have an infiltration system where the runoff from the river, from the roads, goes in an infiltration system which is made up of sand and then slowly flows into the river and absorbs all the runoff, all the pollutants, and reduces the impact. Here are some examples where this has been happening. So this is traditionally what we do, and you can see the kind of pollutants which go directly into the stream. So if you don't do that, you can do a big thing. This is in New Zealand here, where they started to look at the central lane for infiltration of the runoff from the river so that it doesn't pollute and flood the lower part of the city. This is how we do these infiltration systems. We dig out these compartments, we fill it with sand and gravel, and then we grow the plants, and the plants actually don't need to be irrigated because there's always a bit of water, even in a dry season, flowing through here in the subsurface. And it makes a much nicer environment, as you can see here. So this is how some of these systems look like. So that gets me to parking lots, and parking lots are very, very nasty things because not only do they allow the water not to infiltrate, everything runs off and the pollution is huge. So what we do now in parking lots, we kind of say, well, all this stuff can be actually infiltrated into these swales before it goes into the river. A very interesting one I learned is this one. What they did here, they built a swale to infiltrate everything, but then they grow willows. And I don't know whether you can see this, but there is an awning here. And what they're doing is the willows will grow over the awning and provide shade of the parking lot. So not only does it help you with the infiltration, it will help you to evapotranspire water, and it provides shade so that the temperature are moderated so that you don't cook in sitting in your car. And so we're now building wetlands in the middle of the city to absorb all this runoff from all the roofs and surfaces and allow it to actually infiltrate or detain and purify. And this is becoming a big interesting activity for recreation, and encourages biodiversity, encourages birds and so on, makes a far nicer urban environment. Here are some of the wetlands which we helped create with students, which actually do quite a good job. The students would measure what's coming in and what's coming out and how effective are they and what type of plants can actually take up most of the contaminants. Protecting wetlands is absolutely critical because they are the lungs of the world. And so people are worried about building wetlands in the middle of the city because they all say, well, this is just going to increase mosquitoes and disease and everything else. And if there is a lot of nutrients coming in, you're creating all this kind of eutrophication, which obviously creates even more mosquito problems. So we now understand how to actually build wetlands in a city to minimize mosquito problems. And the first thing is prevent stagnant water. So water should always be flowing. And the way you do that, you have a solar panel there or a windmill like here, which makes the water move a little bit. Secondly, you need to skim off the eutrophication and try to reduce the amount of nutrients coming in. And then you need to put in a wide range of plants because some plants are really effective and some are less effective and some are good for mosquitoes and some are not. So if you have lots of variety, it helps you with dealing with the mosquito problem. And then you have to make sure that there is open space between the plants so that the UV light can get through, and that also reduces the mosquito problem. And then you can introduce some fish, those which can tolerate some reasonably nasty conditions, and they eat a lot of the eggs and the larvae, and you might want to control the larvae stage by either skimming them or using a benign pesticide. So we can actually reduce that problem quite quickly. We now have materials which allow the water to penetrate, a pervious pavement. And again, this is a new thing. It's a bit more costly, but has possibilities. So that gets me now to the watershed scale, and this is the real problem. We have been channelizing rivers. And so the big problem with channelizing rivers, you're just accelerating the flow. And so what happened here is they built protective walls, and then it flooded again. So they built more protective walls, and then it flooded again, and they will build more protective walls. Well, how much more protective walls do you want to build? We need to start thinking about renaturalizing the streams in the mountains. This is the functions of rivers when you channelize them. Only about 4 functions operate in a channelized river. If you have a more natural river, you have all these other functions which allow the water to go sideways, goes into groundwater. You can do all kinds of diversion. So channelizing river is really bad, and you should avoid it wherever you can or minimize it. So we're now advocating that if you really want to have a successful stormwater activity, make your buffer zone as wide as possible. These are all the functions which a buffer zone can make. A small size can reduce the noise. It will moderate the temperatures if you can grow trees around the buffer zone. It will take up nutrients and sediments. It will retain you can actually build wetlands in the buffer zone, and it reduces the pollution, and it creates all kinds of biodiversity. Our regulation in the city is 30 meters of buffer zone, and we're now saying if you can have a 100-meter buffer zone, you can actually help reduce the flooding problem and the pollution problem in dramatic ways. So again, good buffer zones is a really critical thing, and typically this is the 30-meter buffer zone, so this is pretty good for 30 meters, but when you go to 100 meters, you can see the inclusion from impervious surfaces, from urban development and industrial development and so on. So when you look at buffer zones, you have to think of 3 things. Some of the water which goes into the river comes as surface runoff. In the urban area, this is very large because it's impervious. Some of that water goes through the soil and then seeps through the soil into the river. That is much slower and is much more purified. And then, of course, some of it goes into groundwater, and that groundwater will eventually reach the river, but at a much lower pace, and is also much cleaner. So that is the reason why we need these large buffer zones. So Here's an example in New Zealand where they actually have started to look at a really big buffer zone in the middle of the city, and they created wetlands in the buffer zone to retain the stormwater and so on. So we have channelized all these rivers in the past, you can see this, right? And now we're going to rehabilitate so that the river can flow in a much more natural environment. And this retains not only the water during storm, but it creates all kinds of habitat for fish and for biodiversity. So we're now looking in the city, where can we actually store water during very, very high storm events? Because we don't want that water to go all the way into the lowland and flood all the parts of the housing. So golf courses are a wonderful place where you can actually store water during a big storm event and then release it after the storm is over. And then you only have a little bit of sediment to deal with, and the nutrients from the runoff are probably pretty good. Of course, the golf course people don't like me when I say this, but we can use parks, and these parks can actually be rehabilitated very quickly. They're much cheaper to manage than building all this infrastructure. Case in point now, we are now saying we should design floods rather than building structures to prevent them. This is an example on the Mississippi River. They were expecting a huge, big flood in 2012, and that was going to inundate something like 70,000 houses below. So what they did, they breached the dike here and allowed of the rainfall to flood an agricultural area. And then 2 weeks later, when the peak disappeared, they breached the dike here and released the water. This way they were able to prevent the flooding of a large area of urban environment. And within 6 months, the farmers were back in business. They got compensated for the damage, and within a year, they were back in business. That is far cheaper than building more dikes and more structures, which will never work. So what we're doing in the city now is we're saying, where are all the depressional areas which are not developed yet, parks, low-lying areas, which can be used for temporary storage during these very big events, which are coming more frequently. And so this is a very new way of looking at storm management. And I would encourage you to think about this, particularly in the mountains, because if we can store water in depressional areas for a temporary basis during the storm, you can release that water later on and will make much less impact downstream. So what we've been doing is we have been modeling this. So again, here is an old house, and it was converted into a new house. So it went from about 41% impervious to 55% impervious. And then we calculated how much water could be retained and reduced from runoff if we do all these low impact designs like roof water harvesting, rain garden, soil, trees, the whole thing, all the things you do at the property. So when you do that, we looked at how much water would have been run off from this site before the urban development, and it was that much on a yearly basis. Then the old house, which was 41% impervious, generated so much runoff. The new house generated this kind of runoff. If we now would select several of these low impact designs, or all of them, we could actually get below what nature was doing before, because we are improving the infiltration, we are adding soil, we're doing all kinds of retention. So this should give you a bit of an idea how we could actually reduce the amount of water which goes into the river during storm events. So the interesting thing in our part of the city, the houses last about 50 years because they're all made of wood. So most of the houses in this part of the city were built in the 70s, and they're now getting old and decrepit like me, and so they need to be replaced. So in about 2020, 2030, we were going to have a replacement of lots of houses. And here is now the opportunity for the new houses to do all of this innovation. And so that means we will then have obviously much less problems with all this infiltration situation. So in summary, for managing urban stormwater, think of it in a scale context: property scale, neighborhood scale, and watershed scale. At the property scale, you can do rain interception by trees. You can have green roofs. You can roof water collection. You can soil improvements. You can have rain gardens. You can reduce the impervious surfaces by using impervious pavements. At the neighborhood, which you have to deal with different surfaces, no curbs and gutters and manholes in drainage pipes. Smaller roads with less swale to reduce, and with swales, not only to reduce the impervious surfaces, but also to retain some of the pollutants. Use detention ponds and wetlands because these are really effective in reducing the amount of water discharged, and they accumulate and permanently store carbon, and they take up CO2. Pervious parking lots and draining the parking lots into swales and infiltration systems. At the watershed scale, higher buffer zones, more natural channels, flooding zones which can store water, designate areas for flood storage, wetlands in the buffer zone, and reduce the impervious surfaces, and think of design floods where you can store water. Here's a video which you could look at, which we did in our city. We kind of went around and took videos of all the innovation which is going on. As an example, this is not a Hollywood production. It's the first video we did a few years ago, and we never did a video before. Now you can do it much more efficiently with your sophisticated cell phones. Water harvesting can be done in mountains all over the place. We did it in Nepal because remember, in Nepal you get all the rainfall in 4 months and the rest of the year you got very little. So you can actually collect the runoff, the excess runoff, store it in underground systems or in ponds, and then use it for drip irrigation during the dry season when you have no water. Or you can collect roof water for drinking water and use all kinds of things. I put together a little textbook on integrated mountain watershed management, and it's a web app system, and it is totally available. I made it open access, and you can actually watch it on your cell phone. So if you find this of interest, go to this site, and it is a bit of a textbook giving you all the kind of things which I think are important in mountain watershed management. The good thing about this thing is it's not like a book. When you write a book, that's the state of the art for the time being. This is now a web app where I can, over my time, add new information as it becomes available. For example, next month when I have a bit more time, I'm going to put in the part of this new climatic event. So you can always update it. And I would encourage you to start thinking about doing this for communication, for all these other things. If I can do it, you can do it better because you are much more sophisticated on this digital world, on creating apps. And this is relatively easy to do now and is a very good way to communicate. So use it if you find it useful. The part of the information I've provided to you will be available to the course. I will send it tonight to Danilo, and obviously this might help you a little bit in trying to help address all these big efforts of climate change. So I'm open for questions.
Thank you, Hans. Other questions on this part of the lecture?
Yeah.
I think everything is clear.
Everybody's exhausted and doesn't want to ask more questions.
If you agree, maybe if you don't mind, we can stop 5 minutes now, so you can open I guess, your next presentation, and then we can go on and to the end.
Yeah.
We can stop at 5:30 to allow further questions. Okay.
Sure.
Okay. So 5-minute break, and then we go back to the talk. Thank you. Please.
Okay, so think about citizen involvement in integrated watershed management. What can you do? You can help in the monitoring. You can help in restoration of streams. You can help in the construction of wetlands. And you can volunteer and work in water conservation education. And I will start off with the following. There are lots of people in the world who like birds. And some of these are people who are incredibly knowledgeable about different birds. So what is happening now to the science in bird activities? Well, everybody who has a cell phone can actually take a picture of a bird, and these bird experts, these are people who are retired or whatever, they have an interest in birds. They now can take a picture of a bird, and that picture will tell them the location digitally. These guys know exactly what the bird is, and if they don't, they actually find out what it is. They can actually record the sound, and you can now have millions of people everywhere in the world compiling data on birds on a global scale. This is phenomenal. They now have a website where you can put a picture of your bird, and some of these experts will tell you what the bird is. They tell you, you can even look at the app and it gives you the sound and the name and the habitat and the whole thing. This is a phenomenal way of getting new research data, which a researcher would never ever accommodate by himself. So what can we use a similar kind of an approach in integrated watershed management? That's something you need to contemplate, because I feel that's where we can make a huge impact as far as the environment is concerned. Now, how come this doesn't work? Here we go. So the traditional approach has always been the engineering approach, and now we need to look at the more natural thing. And again, this is where you can actually help. So often when you look at your watershed, there's a lack of data. There's very little information on your glaciers. There's virtually no information on groundwater and mapping and monitoring. There is very little data on water quality and little data on flow, particularly the long-term data. There's very little information on water use, both domestic and agriculture. There is no metering or very little metering in water accounting. If I ask you, how much water do you use on a daily basis? I bet you probably can't tell me that. And there's little monitoring and enforcement of all this thing. So community monitoring can actually be done because we can actually get you involved in water quality monitoring, aquatic organism monitoring. We call this the cabin approach, and I'll show you later how we do that. We can actually involve you now in measuring how much water goes down the river using your cell phone. And we can look all kinds of geospatial analysis of your watershed if you collaborate with either community educational groups or universities. So what is really happening now is we want to collect data and put it in a common database so that it is available to everybody. So we would like to have a digital database that is accessible to community groups, to academics, to industrial and government agencies. And usually governments have created all the data and they built the database, and that's often not available. So now community groups can actually put data into this, academics can put into it, industry can put into it, and government can put into it, and then means we now have a much better understanding on what data is available. And then comes the difficult part, and that's synthesizing and evaluating that data. That is often more difficult for citizens to do unless they have some help with academics. So the interpretation and evaluation and modeling of the data usually is done either by academics or scientists or consultants in collaboration with scientists in governments. So building a new set of data information which is publicly available is absolutely critical, and this is now happening in some parts of the world, and we need to encourage that very much. So community-based protocols for monitoring. Remember, governments always think when people do the measurements, it is of low quality and cannot be relied on. So what you need to think about is what are the key water contaminants you have to monitor, and what kind of equipment can you use, and can you get the samples tested in a lab that is certified and uses the right procedure. So if you have a watershed community group, you can get a professional to train the citizens in how to actually do that and in how to sample and maintain quality control. We have done a number of training courses on going to the citizens and showed them how you can actually do that and what you can measure, what you cannot measure. So you should be thinking about using existing sampling locations. For example, don't just go and collect the water in one part of the river. Go to a station, a river where there is already a station where they have been monitoring in the past, and also make sure that the infrastructure is there, particularly in terms of hydrometric stations. Because if you don't have that, it's difficult to actually calculate the loading of your contaminants. So if you do this properly, you can create a credible database and use the existing government database as a background and for data input. So make sure the data is shared and made available to all the stakeholders. And so one way of doing this is using the academic institutions for the training and use some of the government agencies to make sure that the quality control is maintained. So community-based inventories, monitoring and mapping can actually be done in many different ways. So typical water quality monitoring by volunteers include specific conductivity, pH, nutrients, phosphorus, nitrogen, turbidity, fecal coliform, and streams. And given the technological advances in instrumentations, this is becoming much, much more easy. And I'll show you how this is being done. Habitat, you could get involved in habitat surveys, looking at, for example, birds. As I mentioned, is now very easy, but you could do exactly the same thing with all kinds of plants. If you're interested in plants, you can actually help map the riparian vegetation in your buffer zone. You could do a land use assessment, because many of the things you can now do by either available LiDAR or satellite imagery. Again, you can do fish surveys or buck surveys or bird surveys with all these different kind of things. So because there is a lack of scientific information on all of these different things which I mentioned, here is community initiatives. Watershed monitoring, water quality monitoring, invertebrate analysis, geospatial mapping, water conservation, local food production, inventories, wetland enhancement, climate adaptation, lake monitoring. So we've trained now a number of young people to look at aquatic organisms, particularly invertebrates. Like I mentioned, invertebrates don't move very far. They stay in one part of the river, and the invertebrate biodiversity tells pretty much what the health of the system is. When you do water quality monitoring, you almost have to do this on a continuous basis, because depending on the flow of the river, the quality and concentration is very different. Those invertebrates are there on a permanent basis, and if the diversity of these organisms change, that means the water quality changes. And so you could start thinking about this as long-term indicators of environmental quality, where you do this maybe twice a year at the low flow and at the high flow, and then look at it in this way. So the method is simply have a kind of a screen. You pick all the rocks above your screen, and whatever is collected, you can actually analyze. What we've done is the environmental agency of the government is actually doing this on a regular basis, but they only do it in very few places of the river basins. So now we ask them to train the individual citizens on the method on how to collect the organisms. And then they train them on identifying the macro invertebrates, the easy one which you can identify. And then they send these samples to the government lab, and then the experts will evaluate all the detailed micro diversity. And so now, all of a sudden, we are able to have gone from about 20 sites where this is happening to several hundred sites where the citizens go out twice a year, collect these organisms and put it into the database. And now we have far more information on that as a long-term way of monitoring water quality. So the other thing which is happening, which is quite exciting, is there is now all kinds of new tools which are all digital to measure the pH, the conductivity, nitrate, orthophosphate, the turbidity, DO, the dissolved oxygen, and some of the metals in sediments, which you can actually do with an instrument with very little training. So you can actually generate the data. And this is now the invertebrates, which I just explained to you. The other thing which is happening now is we have all these tipping bucket rain gauges. These are automated rain gauges where you have a data logger and you can put those up anywhere, and I can provide you with very interesting information on the amount of rainfall and the intensity and duration of the rainfall. Very easy to install. Needs a little bit of help in data downloading, because you don't only need to download these things about every 3 months or so, and you just have to make sure that everything is clean. We had a very interesting experiment in Nepal. We put up about 20 of these, and then one of the systems showed a huge rainfall event. And we couldn't explain that because there was no rain anywhere else. Well, it turned out to be that one of the boys didn't know what it was and he peed into it. So you never know what you get. So here are some of these instruments which allow you to do these measurements. Here's a multi-probe for water quality. This is for turbidity. This is for temperatures. We now have these little temperature recorders which measure the water temperature every 5 minutes, and it gives you a very nice profile on what is happening in lakes. Citizens are now measuring the turbidity of the lake on a daily basis, and all these instruments now are readily available, and they're easy to use, and they can actually be directly downloaded onto your cell phone and put into the common database. Here is another way in which you can start looking at sediments. Sediments are very important because they absorb a lot of pathogens, as I mentioned, and they also absorb a lot of metals and other contaminants. But measuring sediments is very difficult because if you go tomorrow, the river might not have much sediment, and then during a storm, you might not be there at the right time to get the right sediment. So one way of dealing with this in small rivers is you build something like this. You put it in the river, so the river comes down this way. Here is the opening, and here is the outlet. So the water will flow through with the sediment and will deposit the sediment. So you could actually collect an integrated sediment sample over a storm period of maybe a few days, and you get a sample which you can then analyze for contaminants, which would have been very difficult to do if you do it in surface sample in a sampling process. The other thing you can do, and this is what we have been encouraging our community groups in the Columbia Basin to do, we have a college in the middle of the river basin who teaches GIS. Well, they have 20 students every year who have to do a project. So we told them, why don't you do a watershed map of all the community watersheds? Not only can you do a watershed map with GIS, you can do a slicing. This is an elevation slicing of this particular watershed, which shows you the high and the low elevation. It gives you how much area is at this elevation, that elevation, and so on. You can also look at the whole water network. You can put in the stations, and you can look at the land use, and over time, you can look at the land use changes. That will give the community groups information on what the potential problems are when they look at the data from what they're doing monitoring, and this will be incredibly useful for persuading the public and the government agencies on the changes which are taking place in your watershed, both in terms of land use and in terms of water quality. So here are some of these different activities which community groups can do. They can advocate, they can educate, they can do pollution prevention, they can do the monitoring, and they can actually help in restoring many of the degraded areas. So advocacy is one aspect. education is another aspect. You're not only educating the community group who is doing it, but you're then educating everybody associated with the volunteers. Here are the strategies for agencies, and here is what the community groups should be doing, and it needs collaboration between government and citizen groups. And you need to have people in the government who are willing and open-minded that this approach can actually help. And this is starting to happen. It's not happening very fast, in my view, but it should happen much faster in the very near future. We now have an app in the cell phone, which you can take your cell phone to the hydrometric station and you put on your video and you can actually determine the flow of the river on any time of the day in any different ways. And this allows us now to get flow data which we were never able to get before unless it's an automatic station. So all kinds of new opportunities using these new technologies. So remember, we not only want to monitor, we want to look at how to improve the buffer zone. And again, remember the buffer zone has to be large and has to look at both surface runoff, subsurface runoff, and groundwater. Here's an example of what we need to do to rehabilitate buffer zones. They channelized this river, and now it doesn't function like a natural river. So then they decided maybe we should diversify this river a little bit. So they bought the land on both sides and created something like this. This is helping a little bit, but it's not sufficient. It should be done on a much wider scale. So we are naturally things, create back channels, new habitats for fish and everything else. The problem with this is extremely expensive if people own land in the buffer zone to persuade them to give up part of the land, particularly the agricultural part, for biodiversity. But this is one way in which we can do it. My suggestion to you is if you are in an undisturbed area, rehabilitation is far more difficult than protection. So why not protect those areas that are not yet disturbed and rather than rehabilitate, but when it's already disturbed, we need to rehabilitate. So here is what some of these citizens are involved in: restoring and designing and so on. So voluntary cleanup, streamside planting. We're now planting lots of trees in the buffer zone. Habitat reconstruction, fencing along the buffer zones to not allow all the animals to get directly into the stream. So here are some of these restoration things which citizens are heavily involved in collaboration with either consultants or government agencies. So we can build side channels, marsh wetland benches, overhangs so the fish can hide. We can do in-stream complexing. We can add spawning gravel and fencing. Here's some examples. This is the design. Here is the action. Here is the purpose. Here is the construction. So again, in collaboration, this is easy to do. In the past, we have removed all the debris in rivers because we thought it's bad. Now we're actually putting in trees and we anchor them because this creates organic matter and creates habitat for fish and everything else, and also diversifies the stream flow, creating more pools and riffle systems which are critical, helping mimicking nature, creating more diversity. Fencing is very important. Again, that's the purpose. This is the construction. What is important is many farmers have fields on both sides of the river. And then the problem is the animals like to spend a lot of time in the river and poop into the river, which means they create all kinds of pathogens in the river. So what farmers were asked to do is, well, they have to build a bridge for the animals to go across. Well, that's very expensive. So one of the easy solution was, why not fence off the upper part and the lower part for a pathway of the animals to go from one field to the other and fill it in with gravel? Why would you want to do that? Animals don't like to walk through gravel, particularly cows. So they spend less time in the river, and this is a kind of a less costly solution for farmers who have land on both sides of the river. Again, fencing off is a very important part, and the volunteers can actually do this. Building benches and marsh areas is very important. Again, purpose and construction. Here is the actions of planting some of these marsh vegetation. Riparian buffer zones. Here is where you can actually do a lot of tree planting, which will be absolutely critical in terms of reducing the CO2 emission, helping climate change, and absorbing precipitation to reduce the runoff. And then building side channels, which is very, very important because it's in the side channels where most of the habitat and the fish and so on survive. Here are some of the actions which citizens are involved in, and you can see what it looks like during the construction and after it was completed. Gabion walls can easily be built, and again, where a lot of people can participate. And the interesting thing we found now is we got a lot of retired people, and I would suggest that the population between 30 and 50, that is the population which is now the working population. And they are too busy with what they're doing. And they don't have much time to spend on the environment. The retired people are now starting to think, well, we did a lot of bad things, we should help the environment. And many of the retired people are professionals. And the young people also want to change the environment. So if you can combine the retired people with the young people, you got expertise and you got both of them interested. They are actually the solution to solving all these rehabilitation problems because they can bring in all kinds of knowledge and enthusiasm to do this. So managing of wetlands is what this all has to do. This is an attempt we did in 3 days in Honduras with a bunch of young people. We built this wetland within 3 days, and Maria Cecilia, who will give you a talk in a few days, was actually instrumental in helping us with this. And once we left the project, these young people actually built 3 or 4 more of these wetlands. So here are some of these which I showed you before. So restoration is a very good and very important part of what we do, and governments often do not have enough resources and manpower or women power to actually do the rehabilitation. And so watershed restoration is a key component of the stewardship program, and the restoration must be site-specific and self-maintaining. In other words, when you change the things, make sure that you don't need to change it on a continuous basis, that it is benign and following the natural processes. Restoration tools can be channels, in-stream habitat, stream banks, buffer zones, whatever. Successful implementations requires financing and partnership and communication incentives and so on. And we're now getting some financial support from NGOs, from foundations. Even governments now are starting to put some money behind all these community groups. Monitoring the pre and the post restoration is very important to make sure things work. Our airport was expanding the runway, and the rule was there was a wetland in the base of the new runway, and that wetland had to be replaced because it was a very important wetland for endangered birds. So we were asked to rebuild this wetland away from the airport to the specification of these birds. Well, I tell you, it took us 5 years to get it right because we had very little knowledge on what the exact type of habitat should be for these birds. So the structure of the vegetation, we didn't know how to manipulate this, and it took us a long time to figure out. So we need to monitor, even after we plant the wetland, we need to monitor how this survives in the long term and maintains the process we want to achieve. So adaptive management is necessary for the long-term success of restoration, and there is all kinds of innovative ways we can actually do that. So I leave you with this idea, and I would encourage you with the following. This IPROMO workshop has a wonderful opportunity for you to network globally. You're now all connected, and you now can share all the knowledge you have with everybody else. And so any of the innovative ideas you have in your mountain area, you can share with all your colleagues. And some of these colleagues can actually pick some of your ideas and use them. And so this will build you a new community network at the scientific basis. And this is now so easy to do that I think if you capitalize on this, you can make huge changes as we go along. So give this some thought, and Maria Lara is really keen on fostering this kind of linkages and global communication as part of the mountain network. And I would encourage you to take this opportunity and share as much as you want. All my information will be made available to you. You can use anything you want, and you don't need to acknowledge where it comes from. It's educational material. If it helps you, use it. So we'll leave about 10 minutes for questions because we have a very important speaker coming up in a few minutes. So open for questions.
Thank you really much, Hans, for all the interesting presentation. Not the last one, obviously, but all the big amount of that information you provided every year. Okay, there is a first question from Anu. Is citizen science a refined, digitized version of community stewardship? This looks like a perfect way of harnessing power of digital technology to communicate work done through community spirit.
Oh, absolutely. In fact, there are now a lot of facilities available to help you create a watershed community network. If you go to the US EPA website, they have a website for community watershed education. And it's a kind of a cookbook which tells you how to organize a community watershed network. It shows you what you can do and what you should not do and so on. So there are lots of these new initiatives which will help you develop this strategy. And remember, if we start sharing the information in global databases, this will make a huge difference, not only for everybody else, but particularly for the researchers who need data to do the modeling. You know, if you look at our climate data, the more stations we have at high elevation or more information we have at higher elevation, the more we can actually do to prevent and rehabilitate the area. This is a particularly important area in mountains where the data is very lacking. So remember, you guys are now all digital. You spend probably 90% of your time on your cell phone. Use at least 10% of the time on your cell phone, not on your social network. Do it on your scientific network which you're building. So we should have something like a network like the TikTok or whatever they are for communicating the science and knowledge on mountain sustainability.
Okay, thank you so much. And are there many other questions? Please.
Create a network on Facebook, if you like. Not that I'm promoting Facebook, but create a network on mountain watershed management and share the information there, and you could do a tremendous impact that way. Sorry.
Okay, there are more questions or comments concerning. I guess now it's time to ask questions or post comments concerning all the different topics Professor Schreier presented in these 2 days. You have to exploit this few
Well,
minutes.
the reason why I covered so many different topics is when we start looking at integrated mountain watershed management, we cannot just look at one aspect. We have to look at the integration of all these. And all I have provided you is bits and pieces of parts. What I'm totally incapable of doing right now is how to integrate all of this in a very sophisticated manner. But what I've been trying to use for you to think about is looking at the water resources is the way to look at the integration, because everything we do on the land has an impact on water, on the flow and the quality. And so looking at the water cycle and the water contamination is giving you a very good feeling on the quality of your watershed. And that might be a good way of starting to think about integration of all these different topics. You know, most of the government agencies operate in a very specific resource: forestry, agriculture, tourism, mining, whatever. And when we talk about sustainable mountain management, we need to start thinking about the interactions of all these. And this is why I was trying to give you some ideas in a very simple way, what we should be thinking about in terms of integration.
Okay, any other questions or comments? Okay, if I can, I have one question for you, Hans. It's just a comment. I don't know what. How do you assure the reliability of data collected by citizen science?
Yeah, this is a very important topic. The one way we're trying to do this here is we're trying to find somebody in the government who is open-minded, who is into the regulatory part of the government and uses the professionals in the government to every so often go and make sure that the citizens are doing things according to protocol. And this is interesting now because we have these retired people, some of them are engineers, and they are probably even better trained in hydrometric measurements than some of the government agencies. And so if you can link up the hydrometric people in the government with some of the retired people and build trust, you can actually do that. That's one way to create quality. Secondly, you can do what we did with the invertebrates, where the government trained the citizens and does part of the evaluation and makes sure that the laboratories who do the sample analysis are maintaining a quality standard. So there are many ways in which we can actually do that. A lot of it requires supervision. And this is where the university also comes in, because we need to start thinking about, as individual researchers, can we actually engage people, volunteers in our research? My colleague in the Czech Republic hires summer volunteers in his program, and they're supervised by the researchers to make sure that the quality data which they generate is actually accurate. Think about spatial analysis. If you want to have a water sample in 50 places in your watershed at one time, you cannot do this as a researcher or as a student project. You need lots of women and manpower in order to do that. So you can actually get a much richer database as a researcher by incorporating some of the volunteers. And now we got a lot of people who are actually willing, because they're starting to realize environment is becoming a big issue. So I'm confident that maintaining quality is not an issue, provided we have good supervision.
Okay, thank you. Thank you so much for this, for your answer. Okay, so I guess the amount of information is preventing additional question. No, there is a comment from Anu. Is the idea of citizen science also redefining the meaning of science, as we are relying on many forms of knowledge system, traditional, scientific, like knowledge, etc. in the process? If so, is there an end to add core scientific thinking approach? Is that also a kind of disruption then?
Remember, people who live near the river probably have more local knowledge than somebody in the government who goes out there once or twice every month to do the monitoring. So there is lots of local knowledge which has been accumulated over time, and that knowledge needs to be captured by the scientific community as well as by the government. And so local knowledge, particularly indigenous knowledge, is very important, but it is difficult to quantify. And so, because a lot of it is stuff which people have observed without a scientific verification. And so one of the big challenges we face right now with our indigenous people in Canada, they have a lot of knowledge, but it is verbal knowledge. It's not scientific knowledge. It's not written knowledge. It's verbal knowledge which is passed on from time to time to time. And what we need to do as researchers now is to say, can we calibrate some of this knowledge? I'll give you an example. They were saying they were using a certain plant for food, but they wouldn't eat the bark. They would only eat the inside. So that was good. But then we as scientists wanted to know why. And so one of the researchers started to look at it, and they found that the bark actually had arsenic accumulated, which would be very, very nasty for health. So you doing some scientific calibration of the indigenous knowledge would help us actually and verify that some of the knowledge which has been communicated over time verbally can actually be documented to be scientifically based. So there are some opportunities there to do that, particularly in the mountains where you have lots of local knowledge which has never been verified or scientifically documented.
Okay, thank you very much. There are several people thanking you for all the information. And okay, so some they are working on water, some they are working on snow depth measurement, and for example, they are using this kind of these tools of citizen science to overcome travel restriction, for example. Yeah.
Well, you know, I'm not saying that we can do everything with citizen science. There are a lot of issues which are far beyond what the citizens can do. Just looking at glaciers, you know, very, very difficult for citizens to actually look at some of these issues associated with the glaciers. So there are lots of things which we still need to do in a traditional way, but there's lots of good things we can do at the local scale, which will help us down the road. And so please don't get discouraged here. There's lots of positive things we can do.
Okay, there is another question. It would be the last one. Then we will have a 5-minute break. You said that you collected some data, river runoff and sediments in the Nepalese river using the sensor and the instrument. Where are these data stored, and can we possibly use this data?
Well, we worked on 2 watersheds in Nepal for 14 years. We looked at everything from soils to climate to vegetation to drip irrigation, you name it. If you go to ISI mode, you probably will find a book which says too little and too much water, the problem of development. And it's a book which has almost all of the data. And if not, we have a number of publications. Most of it is in ISI mode. And if it is of use, use it. If you want specific information, email me and I can give you access to some of that data. Remember, we're now in a situation where we can share data very easily globally. And so if you want more information on places like the Andes, look up the researchers who work there. And Maria Cecilia is going to give you a talk in a few days. She can give you all kinds of information on the tropical Andes and so on. So use this network to enrich your experience.
Okay, thank you very much, Hans. I would like to ask everybody to open their microphones and their camera to say thank you very much to Hans, and possibly clap your hands even virtually. But I think he deserves this kind of thank and closing the session. So thank you very much, Hans. Come on, don't be shy.
Thank you.
Absolutely amazing session today.
Thank you so much.
Thank you very much.
so much.
Thank you so much. Thanks.
Bye everyone.
Very interesting presentation. Thank you.
Have a wonderful workshop.
Thank you. Bye for now.
Okay, thank you very much, Hans.
Bye-bye. Thank you.
5-minute break, and then we came back with the final talk of this day. See you in 5 minutes. Okay, welcome again to this second day of IPROMO course. After the lecture from Professor Schreier, we have a short talk by Michele Cucchi. Michele is an alpine guide, a mountain climber, and as as I already told you, he's active in this cooperation project in the Himalayas. But I don't want to steal time to his talk, so I welcome Michele and I give him the floor. Please, Michele, welcome to IPROMO course.
Grazie mille. Wait a second. Ciao everybody, my name is Michele Cucchi. Everybody call me Lungo because I'm a very tall mountain man. I am a mountain guide. I work as a mountain guide since many years, and you can see the white on my beard. So I spent more than 30 years in the mountains, mainly here in the Alps. I coming from the Monte Rosa area, and in my history, mountain history, I've been a hut keeper on the highest mountain hut in Europe, Capana Margherita, on top of Monte Rosa. I became mountain guide, and after that I started to go around the world climbing mountain with people, with clients. I started to go around the world, especially India, Pakistan, Nepal, doing some training course for mountain local people, especially in Pakistan, where I started to work in 2009. After a few experience on in the mountains between 2000 and 2016, 17, I did many mountains, especially in Pakistan. And at the end of this adventure, I climbed K2 in 2014 summer with the Pakistani expedition, and it was, I mean, the biggest mountain experience I had in my life, of course. And this bring me up to other experience in Himalayas. And in 2015, 14, I would say, end of 2014, I started to put together a group of friends, other mountain guides, people who is working in the mountain. And we founded a very little association called Cuore, Attivo, Monte Rosa, mainly with my uncle, who was an older mountain guide who worked in Nepal for 35 years, helping Reinhold Messner at the end of his experience on the 8,000 meter mountains. And after that, he started to work on social aspect in Nepal, mainly, totally in Nepal. I had a different experience, mainly in Pakistan. And together we founded this little association who is working right now in Nepal and Pakistan. What we did in the last 5 years is at least one trip a year in the Himalayas, at least, sometimes more, to try to help the mountain people, mainly with education, that means school, with the water project, that means hydraulic installation for water, drinkable water in the villages, in the very remote villages, and agriculture. Try to help them to understand how is a better way to do agriculture in the mountain. My uncle is very smart on that, and in the case of Nepal, we have a very nice connection with the female ONG organization, Himalaya Education Center, who is based in Kandbari on Arun Valley. So we are talking about the area around Makanlu Makalu and Kansenchonga. The big dream, the big vision is bring to a bigger town the smart girl who wanted to become a teacher. And we are help them to build a new school where the girl, when they become a teacher, they come back and teach to the kids in the villages. So the vision is something like that. And we are doing this since 5 years now. We already built 4 schools in the Arun Valley. We are hopefully, if the pandemic will allow us, we want to go back in November to do another school, pretty much in the same area. Very remote place, very remote area. I will show you. I will show you some picture about that. Yeah. Just a second. Danilo?
No, non si vede ancora niente.
No, infatti. Ho
Allora,
provato a condividere, passa all'applicazione desktop.
Sì.
Firefox o Chrome. Io sono aperto in Safari. Devo chiudere e rientrare con Chrome?
No, ti dà solo quelle 2? Non ti dà nient'altro?
No.
E allora temo di sì.
Ok, allora devo uscire. Sorry
Okay,
guys, I gotta go outside from Safari and come back with Chrome or Firefox. Otherwise I cannot show you the picture. Vado Danilo, esco un attimo.
Ok, vai. Sorry for the inconvenience, but this is a computer science. It's in a
I cannot share the screen with you, so we will probably send you a couple of little images about what we are doing in Himalaya, in Nepal and Pakistan. But in any case, if the pandemic will allow us in November, we want to go back to Arun Valley and build a new school in a very remote and in a very small village for between 70 and 80 kids. And in the same time, we are helping this group of girls in Kandabari, which is quite a bigger city, to keep going with the studies to become a teacher, and after a few years go back to the small mountain villages. The other thing that we did this year with a big effort during the pandemic, I have many friends in India, Nepal and Pakistan, and I understood that the Pakistani were the worst because it's very difficult to do agriculture up in the mountains because it's very dry, and the land that you can work is very little. So we decided to leave Italy in November, early November, and because I know so many people who is working with tourist mountain business, that's mean guides, especially porters, high altitude porters, and low altitude porters. And I knew that they were without work for more than a year. We decided to go to Skardu, and from there make a different trip up in Baltoro valleys to bring food to the families who were in such a bad situation because of because of the pandemic. And we spent a little bit more than a month around Skardu and up in the valleys doing this. Actually, with 5 friends, we were in Skardu for weeks to organize all the things. And thanks to VK2CN, maybe you, there are some Pakistani, maybe they know what I'm talking about. VK2CNR is an Italian ONG association who is working in Pakistan since a long time, mainly focus on environment and the park, the new park organization, Karakorum National Park organization and management plan and all the project connected to that. And with them, with the help of them, we bought almost 20 tons of food in Skardu, and from Skardu with the jeeps up and down in the valley, in the small, very small villages where normally people is working for tourists, to do porters, working as porters and campsite and kitchen stuff and all kind of. So we spent all the month between November and December in Skardu, and then we came back. After that, in this spring, in March, end of February, March, I came back. I went back with again a group of friends, again mountain guides and mountain people, to Pakistan to do the first ski traverse of Deosai National Park in winter. It was a small project trying to push for a kind of tourist, very low impact, really adventure in a super nice area with Deosai National Park. That it's really a special place. Now what we are working on is project in Nepal, as I was saying, in for after the rains. And in Pakistan, we are talking probably in the next probably 2-3 months to try to put together an operation for training for mountain people, training about mountain and techniques and a little bit of rescue and things like that, pretty much. I'm very sorry that I cannot able to show you the picture, but through Danilo and the Freppats, we will do it to you by we transfer or a link in the net, so you can have an idea about what we are really doing. Danilo?
Okay, thank you, Michele. Thank you very much. There is a comment and a question for you, because there is one of the participants, Ghulam Muhammad. He is from Skardu.
Okay.
And he is asking, you said you have been working, where you will train the people in Pakistan?
Where? Okay,
Where?
mainly in Skardu, but we are probably going up to the valley at the very beginning of the Baltoro Glacier. Very beginning, that's mean the villages, the last villages before going up on the glacier. Because there are a huge amount of cliff and rock wall where we can easily work, and maybe we can have a chance in 3 days walking, 3 days trekking, to reach at the very beginning the Baltoro Glacier.
Okay, and who are the beneficiaries of the project?
Mainly high altitude porters. I know everybody of this kind of people in Pakistan after so many years. So for sure he will remember Ali Sapara. Ali Sapara, who is who died on K2 this winter. Actually, he's missing on K2. He was one of our students during a few courses. So if Gulam know and remember Ali Sapara, he can understand what kind of people are the beneficiary of this training. The other nice things that we are doing in Scardo is with a nice, good connection with the 1122, is the emergency service in Pakistan. We are trying to put together a training course for 1122 service. I'm talking about technical things. I'm talking about mountain rescue. Either today, as you see, I am on duty on a helicopter base in the rescue. So this is mainly my job, and I want to try to transfer the part of my experience to people who really needs to have experience and exercise and training and equipment and yeah.
The list is long.
Yeah, the list is very, very long and takes a lot of time. Okay, I can see the chat. Where do I go? Okay, you mean Ascoli, certo? Yes, of course. Ascoli. Either in November we were up in the villages close to Ascoli, and the Usai National Park. Yes, of course. Really, he knows everybody and everything. I'm from Sapara. Okay, you are. Okay, you know what? You can. Why don't you write me your phone number? Because if I come back in October or November, and if you are in Sapara, I will write to you. He was very close to me. Rescue would be great for training our locals program. Yes, but yes, of course. If you know Urani, who climbed K2 with me, or the other guys that are quite famous in the Scardo area. Taki, yes, of course, I talk with Taki. He's leaving Taki. He's leaving today for the Baltor track. Ascension, of course. Too bad that I can. He left today. Yes, yes. Yeah, they left today. Assanjan is now with an Italian expedition on G2 with Marco Confortola. Marco Confortola, who's another climber, famous climber in Italy, right now is with Assanjan. And the others are leaving for K2 right now, today. So the meaning of all these things that I have in my mind and in the dream of this very little small group of sometimes I'm saying crazy people is try to pass our experience, mainly because we know as first we had so much from life. I had so much from mountain experience that after few years in the Himalayas and the mountains around the world, I understood that it's really time for me. Right now I'm 51. It's really time to give back to the people, give back to other people around the world, and especially in this kind of country that life is not so easy. And Gulam know what I'm talking about. And well, this is what I think and what I want to do. I'm just coming back from Peru, where I spent a month climbing mountains. And I mean, it was another wonderful experience. But when you met the local people, the people who is climbing and working in the mountains, you really understand that they really need help to understand, to grow, to do better, and try to have a better life staying in the mountain, not trying to go to Kathmandu or Islamabad or Karachi or Lima. They need help to stay and live in the mountain. this is what I think, and this is what I'm working for. And I'm very happy when I can meet somebody in Nepal or in Pakistan or in Nepal that is creating something in the mountain to stay and live there.
Okay, Michele, thank you very much for this small but really interesting talk. And it's really, as a closing remark, it's really funny because we were started our conversation in Italian, speaking about our world that is really small, and this is the confirmation that this sentence that our world is really small, and it's a pleasure to have you here to exchange your experience and share all this information to our participants. So thank you very much. And concerning the participants, see you tomorrow for a double session. We will have two speakers. I will introduce you tomorrow. I don't want to steal you more time. And thank you again, Michele. Thank you, everybody, and see you tomorrow.